All right, hello and welcome, lads and ladettes, to Celestial Theodolite update number 30. Last week, we left off with discussing the timings of the geometric intersections in which predicts uh, the earlier intersection timing versus the later, and to give an explanation as to why. So everyone's had about a week or so to think about it. But before we get to that, I do want to cover a couple things spreadsheet related. Give me one second here. So special shout out to Embo, who's been going through the spreadsheet, and he pointed out the difference in spherical trig versus the Euclidean projection of a central angle, which is what we're using. Now, they are equivalent for all intents and purposes that we're using, but the fact of the matter is that the angles that we're using will always add up to 180 degrees, whereas on the globe, with spherical trig, it'll always be in excess of 180 degrees. So there was an error there in the derivation for the globe angle, but it was at the decimal placage of like six or seven decimals back or whatever. But anyway, I did change it to use Embo's equation for actual spherical trig, where the angles would add up to over 180 degrees. And the difference between those and the Euclidean projection are given down here. And like I said, the differences are outside of the arcsecond range here. You only need, I think, to the fourth decimal for arcsecond agreement, and we're in like the sixth or seventh. So everything is all good on that. There was a quick update, but shout out to him for going through it and pointing that out. That is an important distinction to make. So shout out to him. Okay, so last week we were going over this animation here to represent the time. So I wanted to kind of back it up and give some significance to what's being shown here. So in the spreadsheet, we have the time of occlusion, all these angles, right? But the big things to take away here are the intersection differences between our predictions. Because when we go back to derive an elevation off of the occlusion angles, there's always an error. So and the same for the distance when we derive the distance. And the same goes for the globe too. But what's the source of the error? How can we simplify it? Well, the error comes from the difference in what was the intersection difference between what we predict versus what was measured, and same for the globe. So when we reference the true position with respect to the peak at the time of occlusion, we get 2 arcseconds in difference. And for the globe, being the observer-based prediction, where the star has already, should have already geometrically been at the angle 217, and now it's at 206 when the occlusion occurred. So they missed their 217 occlusion or intersection window by 11. So when we go on to derive things, this is why the globe is off by that amount, because that's the angle that they're using for the occlusion, and same for flat Earth. So this is what the stem of the error comes from, and this comes from the fact that the stars are lingering, right? They're not following the 15 degree per hour relationship, and there's no real way to account for that other than just saying refraction. But this is the difference in following the actual celestial sphere, and I'll see if I can pull up a screenshot of what Brian mapped out for. But the important thing here is that on this spherical coordinate system, if we take a slice of this circle here down to the radius, we have 2 points that subtend the circumference of the circle here, right? And these 2 points that subtend the circle is called the arc length. And that arc length is proportional to a distance. And you can do that by multiplying out the radius. So I added this here for a little explanation slash, just sanity check really. But here we take Earth's radius times gamma, and gamma is just distance divided by radius, and that gives you an angle in radians, and you can convert that to degrees, which I do in this formula here. And then so all you do is just multiply radius by the central angle, and you get the distance back. So it's pretty straightforward, nothing too fancy, but it's just to show that over this distance here, over this arc length of 27 arc minutes is equal to 50,000 meters. So the distance between the observer and this mountain, 50,000 or 27 arc minutes. So if we go back in time, and we know how fast the star's true position move at 15 degrees per hour, as per the model says. So we know how long it'll take this star to traverse 27 arc minutes in angular difference in the sky, and how long that'll take. So at the end of this arc length, at the end of this 27 arc minute angular drop from its original position here, if we rewind the clock by 2 minutes and 29 seconds, the start of this star at 18:40:38 for the observer, the true position is at 2 degrees 33 arc minutes. And with respect to the peak, it's at 3 degrees. But we need not be concerned with that yet. So anyway, as time goes on, so the drop over distance of that arc length is this half gamma here. So gamma divided by 2, whatever the central angle is, just divide it by half, and that's how much drop over distance there is as an angle. And then you just multiply that by gamma to get what it would be or actually it's slightly different for that. There's a couple different ways you can get what it will be. You can also just do a tangent or whatever to convert it back. But anyway, you just do whatever function you need to convert this from arc minutes into meters, and that will convert the drop over distance from an angle into what it will be in meters. and it's always proportional in that way. So at about halfway, at a minute and 15 seconds of its 2 minute and 30 second or 2 minute 29 second transit, it's going to have dropped 13 arc minutes. And a couple arc minutes after that, it's going to intersect with the peak. I think this puts it at like 219 here at 115. So if you add 115 in time, and this is all added on my new, I made a guide to walk you guys through this here. I'll put a link in the chat. Why the globe predicts earlier time, geometrically speaking. There it is in chat. All right. So anyway, when we, it comes out to like 219 there, and then about 40 seconds later, it ends up at 217, and this is its intersection point where it should have intersected at 218.42.04 is when the globe had its intersection time. So right here, rotate the, oh, where's the one that do the thing I need? Okay, so we started here. It's been about a minute or so, a little over a minute, like a minute 30. The intersection for the globe occurred right here at 218.42. Now, the star didn't, no occlusion, no geometric occlusion. So a little more time goes on because it still has to traverse this central angle. So our intersection differences added up together and as a time converted. So 1 minute, 3 seconds plus 114 there is the, if you add that to the to the 115 for the drop over distance in time, you get the full central angle here of 2 minutes, 29 seconds of real time. So this is how all of this is related. So as more time passes by, it gets occluded within 11 seconds of what flat Earth predicts, real time. And the angular position difference of that comes out to be 2 arc minutes. So the starting true position was 233. The ending true position for the observer was 233. Now, the globe's chance for a congruent triangle from observer to peak to star would have been at 217 or thereabouts, right? The same way flat Earth is a little off. The globe would be a little off like that too. But otherwise, so like basically the error should be reversed. But what happens is the star gets geometrically occluded when it finishes traversing that central angle. It takes the full 2 minutes, 29 seconds to complete that central angle before it gets occluded. You know what's at the end of that central angle on a flat Earth? A mountain peak with an elevation just based off of the rise over run. So that is the difference in timing predictions and why it works out that way. And I have all of it labeled out here with screenshots from Stellarium showing the timing, starting with observer position at time of occlusion. So we know the positions there, and then going through all of it. We just rewind it 2 minutes, 29 seconds, and then play it out from there. And as it continues on, you can read about how, I break down the central angle relationship and the time components there. So you can read all about how the exact time it takes to drop angularly 27 arc minutes is, defined by the 15-degree-per-hour relationship set by the geocentric position of the star. And we went over the definitions of the geocentric coordinates and the celestial sphere last week on that. So there should be no issue there. But then anyway, after I show what it is for the observer, I do the same for the peak so we can see what it's like with respect to the peak. And then at that time of occlusion, it's at 3. Yeah, with respect to the peak, it's at 233. So that's how that works out. And let me check my notes, make sure I don't have anything else to talk about. Oh, eclipses. Okay, so some people are saying it's a straw man to use the geometric intersection difference as a metric for correctness for predictions. Okay, because there's refraction in real life. I don't disagree that there's refraction, but we're interested in the cause of an occlusion, which is the geometric intersection of a source and object doing the occluding. So we're going to read off a couple of excerpts here. So this is from an astronomy textbook here, and this is about occlusions. So an eclipse is distinct from an occultation, which is the blocking of light. And then it gets into the shadow of the moon falling upon the Earth is a solar eclipse, and the shadow of the Earth falling upon the moon is a lunar eclipse. And by these definitions, the solar eclipse is really an occultation. So again, this is relating geometric intersections and the timing in which those occur, which is going to dictate the, when you see the event. So he talks about we introduce the Bessel function or the Besselian elements and all that, the Besselian plane. So they get into all of this, and this is referencing the geocentric coordinates of the celestial body, which is the position is if you could view it with no refraction and see it exactly where it was at. And this is what they all reference everything off. And so just more on that. So this is coordinates for the observer. This is what I mean by geocentric position. You consider an observer located on the surface of Earth at a longitude line lambda. at the geocentric latitude phi prime at a distance rho from the center of the terrestrial spheroid. Center of the terrestrial spheroid. So again, that's merging the celestial and terrestrial sphere models conceptually to make them work. And this is where the geocentric coordinate place that observer at the center of the sphere, and then the angular difference created by radius of 69, or what was it? Sorry, 3959 is what changes the star's position relative to that. So it's all based off of that. Go ahead.
You just said it places the observer at the center of the Earth, but it literally says that the observer is at some distance from the center of the Earth.
Yeah, so they're doing a transformation to the center of the spheroid to make it relatable. Like we just went over the transformations in the last one for the with the CEL-NAV manual where the guy was talking about it. Like what I'm describing isn't wrong. This is how they do it. It's all relative to the fictitious observer at the center.
It's relative to him. Yeah, it's relative to him because that's the center of the coordinate system. But the observer observing the eclipse isn't assumed to be at the center of the Earth. He is assumed to be at the surface, so approximately the radius of the Earth away from the center.
Yeah, so they actually do a Besselian plane transfer or whatever, and they end up doing exactly what I said by putting the observer at the center of the fundamental plane, which intersects the celestial equator, which comes out of the terrestrial equator. So all intersecting, putting the observer in the exact center of the celestial sphere to make the predictions. Like what you're arguing isn't a real contention here. We're saying the same thing. And to use the coordinate system, you have to, the geocentric coordinates, what they're referencing is exactly that. As we continue to read through these definitions, you're going to find that what I'm saying is an exact agreement with what I'm saying.
Okay, but that implies the radius of the Earth is the factor necessary for predicting the eclipses, because if it was different, then the results would be different.
Oh, we have a radius of vision, and we're asserting that it's the same equivalence. So if the Earth were actually geometrically a sphere, you would get different occlusion timings. So we're kind of being distracted from the geometric intersection point I'm trying to make here. So I'm going to continue now.
I mean, I can assert the Earth is equivalent in the shape to a dinosaur, and that assertion wouldn't really hold because, you have to actually prove your assertions.
Yeah, and so we proved ours by the intersection difference in occlusion timing. So we're going to go ahead and swoop your coordinate system that's based off of using a radius value to do computations based on how the stars change at a linear rate at specific angles. So, and if that linear rate were true, and if those elevation angles were physically meaningful, then these occlusion timings would be the opposite. We would be off by the intersections would have occurred closer to the central angle here, or the half central angle, due to Earth, because the star is geometrically getting lower. So anyway, we're going to continue learning about the abstraction known as the fictitious observer using a radius value that could be the center of the Earth, or it could be the radius of your vision, transposed as a linear rate of which the stars would change at 60 nautical miles per degree. All right, assuming perfect uniform. Anyway, the topocentric plane is the apparent or intermediate place where the location of the observer is on the surface of the Earth, not the geocenter. The topocentric right ascension may be measured from the equinox or the CIO, and then the geometric place of the object is defined by the straight line between the center of the Earth, or the observer, and the object at any given time without any other correction. So, lining up that geocentric location with the geometric place of the object, straight line between the center of the Earth, and that goes on to show what they do with the Besselian transformation with the fundamental plane, using that direct intersection between the two, because you need a common z-axis to align it. What we looked at last week for the z-axis alignment. Pull up the unwind. Second. Oops. So they'll put the observer here, and then also the center of the celestial and terrestrial sphere will be here, and they do the transformation from here to here. But because the z-axis is aligned, that's what allows for that nice, smooth transformation there. All right. Let's see what else we got here. Reductions from the positions, from the, I think that's barycentric to the geocentric coordinates. So proper place. The proper place or virtual place represents the position of the planet or star as it would be seen from the center of the mass of Earth at some date. This coordinate system is defined by this acronym here for just establishing, geocentric coordinates, assuming that the Earth and the atmosphere were transparent and non-refracting. So again, using the true position intersection, not the apparent position of what we see, to make the predictions. And this is from the supplemental nautical almanac, or the explanatory supplement to the nautical almanac and ephemeris. So the geometric position is derived from the actual position at the time of observation, the apparent position in which the observer situated at an origin of coordinates would theoretically see the object, the astronomic position in which the corrections have been made for some small terms of aberration or whatever they need to adjust in their tabulated catalog for the star positions. The apparent position is derived from the geometric position by the application of corrections for aberration where relevant for refraction. So again, this is how to adjust where, how to compensate for where the star is apparently versus where it should be with respect to their coordinate system using that 15 degree per hour deviation. So however, refraction is dependent on the observer's local reference system and is invariably treated as a correction rather than a blah, blah, blah. So it just goes into that a little bit. But again, exceptions only occur for this phenomenon that are essentially topic-centric, such as the rising and setting, in principle that the correction is neglected in practice for eclipses and occultation. For the geocentric coordinates, parent position of the is in the direction of the for the geocentric coordinates, the apparent position is the direction in which the observer at the center of the Earth would see the object, and refraction does not enter. So, astronomy is based upon geometric intersection timings, irrespective of refraction corrections. Those are added locally after the fact where the observer is going to be, and those will affect how the event is perceived and whatnot. I don't disagree with that, but the actual predictions start with geometric intersections as a fundamental principle, right? And then here's a diagram of what the Besselian coordinate system looks like with that fundamental plane and the observer intersecting here to make the predictions. I'll be for realsies with you guys. This one doesn't make a whole lot of sense to me, but fundamental plane, observer here, that's the important part. Now here we have Fred Espenak from NASA, or sorry, he's not from NASA. NASA cites him as as to the accuracy of their ability to make eclipse predictions. And this is all he gathered was different data sets from all over the world, from different times in history, from different civilizations that had their own charts for plotting out eclipses, because all you need to do is make the observation and then make another one, and then you could predict it out from there. Shane has a short video on it. It's pretty straightforward to make eclipse predictions. But so what he notes here is the geocentric ephemeris for the sun and moon, various parameters, constant, and the Besselian elements are given in the table of the elements of the eclipse. The eclipse elements are predictions and were derived from the DE200 and the LE200 in the Astronomical Almanac in 1984 and thereafter. Unless otherwise stated, all predictions are based on the center of mass positions for the sun and moon, with no corrections made for the center lunar limb profile or atmospheric refraction. So what he's saying here is that at this, like the sun has an angular size, sun and moon have an angular size of half a degree. At the center of that half a degree is what they're using, and then not assuming any refraction correction, anything like that. So using its geometric position to make their eclipse prediction. So this is what it's all based on, what it's always been.
That's not what center of mass means at all. A center of mass means the actual physical center of mass of the object, like inside of the object.
And would you represent that as one of these center points in one of these? Because that's all that's being referenced. That's exactly what it means. It means the exact center of the geometric position of it. There's no different from what I just said. You just corrected me by saying something slightly different and attributing mass to it as like a three-dimensional sphere, completely irrelevant, not shown here. It's all done through circles and hence being at the center of the spheres.
This what you have here is the transformations that you make on the numbers in the ephemeris, so the tables that show you at what angle an object will be. But the ephemeris in the first place are derived from a model of the solar system where you have to include the physical positions and sizes of the object. So he's describing this previous step. How do you derive ephemeris? What you have here is what you do with ephemeris after you already have them.
I see what you're saying.
Can you guys still hear me? Oh yeah.
I see what you're saying. So the gravitational center of mass position, so like the Berry center, right? Imbo?
Oh yeah, that's what I meant.
Right. Okay, yeah. And to get that though, you have to start with observations from Earth to get that, assuming the non-refracted positions to set everything up, and then you'll have your ability to predict, the gravitational position based off of those known true positions, not the other way around. It literally all started with.
I mean, no. If you don't account for refraction and you want to measure distances to celestial objects, then you will get inconsistent results.
You're
so
saying
that's just a
something
completely
completely
baseless
different?
claim.
No, you're saying something completely different. We were talking about center of mass as the point for the prediction versus the true position geometrically as defined by the 15 degree per hour relationship. And I'm saying that the center of mass position can only be derived after you have a true position for the, just the raw where the center of it is using that 15 degree per hour relationship, the backbone of the whole thing. And then you responded by saying something completely different that were related to refraction, which we're talking center of mass. Like, so I don't know if you're not paying attention or if you're just saying different things and hoping that I'm not paying attention, but that needs to stop.
It's definitely that one.
You need to stay on point, because that's the second time you've done that tonight. I'm not going to keep letting it happen. That's super annoying.
I say what I wanted to, so you can continue, I guess. Whatever.
Thanks. I will. So the backbone of all of this is based off of the geocentric positions. Without that, they have no ability to say, hey, we're going to use this reference frame for the center of mass. The center of mass with respect to what? You need the geocentric position to establish it first. End of story. All right. So, are there any contentions about the geometric intersection being earlier on a globe? Does everyone understand what I was saying last week about this? Like, you can disagree as to why it occluded later saying refraction and whatnot, but geometrically, do you guys understand that if the Earth is a globe and Earth curvature is causing the change in the position of the stars, then as it's following the curvature of a central angle as defined by 2 points on that sphere, this angular relationship occurs for the star and the peak at an earlier time relative to the observer. Any objections?
I feel like nobody will agree with this. People just are too tired and think this is like too pointless to debate. That's why they don't have any contention, because it's just so.
Has that been the case the whole time when no valid
Yeah.
contentions have been raised and people just doing dog shit tactics the whole time?
Actually, that's not the reason. The real reason is because you can go into Stellarium and verify the angular relationship and the time, which I've done meticulously and linked here. So the actual contention is that nobody actually has a contention. They just think that it should be later because of refraction. So saying that this is geometrically impossible, et cetera, nonsense.
Like nobody's disputing that, like the geometric, as far as I can tell, the geometric thing, but we're disputing the geometric matters because you're using a visual observation, so it has to be visual. Like,
well, everybody disagreed last week with exactly what he just said.
Yeah, first of all, everyone disagreed last week, and second of all, we're interested in the cause of the occlusion. That's why we referenced the geometric intersections. Now, the globe had a geometric intersection window that was passed, so we have to go to the mountain peak and check ours at the end of the central angle and see where the star's at. And if it's at the same angle, then that's a congruent triangle from star to peak, from peak to observer, which it would only be possible if the Earth is flat and the star didn't actually angularly drop.
Well, it's not that there aren't any contentions, because as you said, there were many raised the last time. It's just that we know that you know those contentions, and I don't think this is worth repeating again, because this entire thing.
What's the contention then? Is it not geometrically, like, how is it? You agree that this occurs, so there's no contention.
It's teleporting the observer to the peak, and like everyone in this discourse knows that you do that. But it was repeated so many times too, and you still ignore this. That's like nobody does that anymore.
Yo, Embo, you're not gonna just come here and say a bunch of random shit. We go to the peak because the star traversed its central angle and got occluded. It has a chance to get occluded at 2 points during this central angle transit of 27 arc minutes. It has a chance at, let's see, 218:42:04. That's when it has a chance, and it has a chance when it lines up with the peak. And we check with the peak. If you have a problem with checking with the peak, that's your problem, dude.
Maybe I'm missing something. Why are there only two? Yeah.
Why are there only two? Because the star's light source is only going to intersect with the globe at this time, or at this time on a flat Earth.
Oh, one for globe, one for flat. Okay.
Yeah.
Isn't that helpful, seeing the alignment of all those three things that people kept confusing and muddying and switching between, how they're all related distinctly?
So last week, everyone was saying that, this was geometrically possible, it couldn't happen, yada, yada. Now, we can all see that this is what happens. This is what the globe predicts based on the observer, based on what they're saying the drop over distance is. All the math and angles and all those relationships are all on here. None of them are incorrect.
As far as I'm concerned, the globe predictions for the geometry, like ignoring refraction, aren't incorrect. They seem to be correct. But if you want to say that the globe will predict it sooner than flat Earth, then you not only have to compute the predictions for the globe, but also compare them to flat Earth. And the only thing you have here is a globe. Because if you were to show the same thing for a flat Earth, then all of the people here would see it's absurd. Last time you tried to do that, you had to teleport the observer to the center of the Earth for some reason.
Buddy,
in fairness to him,
hold on 1 second. Let me start with this immediately. Okay. So the backbone of the globe is the geocentric transformation to the center of the globe. That's what we just read about. That's what all this stuff is. That's what all this geocentric coordinates is. This is what the beginning of this Umlin paper is. So if you have a problem with going to using a fictitious reference frame to explain that, that's one thing. And that's not even what was necessary to do in that diagram last week. We're already using the same coordinate system to show it. So what I'm showing you, what's shown here in Stellarium, starting at the top are all the observer positions at the relevant times at the observer location. And then down here are the ones for the peak. That's all that needs to be shown. It's not going to be a different thing. We're using the same conceptual model for the movement and testing the difference based on the time of occlusion.
You're not using the same thing because you're using the peak for the flat Earth, but you're using the observer for the globe. But the observer is the place where
that's what the globe predicts, though. You understand that? And using this intersection timing here for what the globe predicted, it didn't line up. This is your only shot for a congruent triangle on a globe. This one means the Earth is flat. This one means the Earth's a globe. This one means the Earth is flat. Do you understand?
Okay, let's just ignore refraction for a moment. Yes, this is what the globe would predict without refraction. But this still doesn't change the fact that the prediction for the flat Earth for the opposite thing is incorrect. Like saying that you got the globe prediction right doesn't change the fact that you got the flat prediction wrong.
Dude, what are you even saying right now? We got the globe prediction right, but the flat Earth prediction wrong? Buddy,
yes.
This means the Earth is a globe. This means the Earth is flat. It's that simple.
This is the first time I've heard that the flat Earth prediction is wrong, though.
That's the intersection difference.
Is this because we're wrong, because we're right or whatever? Or what do you mean? How are we wrong?
Well,
and also, real quick, just to touch on the refraction thing, I don't care that you can add 2 different corrections, terrestrial and celestial refraction, to give the appearance to match our angle. We can raw dog it with rise over run to the peak every time, and we're closer every time with no corrections. And the reason for that is because this light source relative to the observer isn't physically dropping. And when it gets occluded, we go, hey, what was the star's reference at the end of this central angle here if we were to check? Oh, look, it's at 233. Interesting. That makes a congruent triangle. Shane, can you pull up the video of the congruent triangle diagram?
What?
One
Oh,
quick
you
question
didn't
on
do
that point. Are you asserting that the globe needs congruent triangles?
I'm asserting that if the Earth were a globe, that this occlusion would have occurred earlier, and it would have created the only way for there to be a triangle where the occlusion time, or the intersection time, the intersection angle is equal to the mountain elevation for a globe. There's a specific time in which that would occur. Anything
That would
else?
make a congruent triangle because refraction bends things, so it isn't like a.
It's a geometric intersection, big dog. So
Yeah, no, I
even
get
if even if it is refracted a little bit, it doesn't. It would have to use up the entire amount of refraction as prescribed. We've been over that many times on here. And when you account for refraction, then or astronomical refraction, then the star is 1 arc minute over the peak, which comes out to be 7 real seconds. So it's geometrically over the peak by 1 arc minute at that time. So it should still be visible. And this continues on. Like, that might seem like a small amount, the 1 arc minute, but when you go over different peaks, it varies to like 2 to 3 and sometimes 4 arc minutes. So the intersection difference there is inconsistent with what is asserted, because then you're just saying that it magically cuts off the refraction amount to be close to what the flat Earth predicts.
Actually, there's a question for you. Just look, I haven't had a chance, unfortunately, to go through the spreadsheet in detail, but why are there 2 globe prediction times on there?
2 globe prediction times. Let's see.
Row your cursor on.
Yeah. So the first one is for the geometric intersections using true positions in the observer base position, and the second one is using the refracted position at the observer location. Because a lot of
Okay, so with refraction, globe is more accurate than flat.
No, it would be
for that one. The time difference is 7 seconds versus 11.
It's geometrically over the peak. It still hasn't set into the peak yet, so it would take 7 more seconds. So now you're saying that instead of using all 12, almost 13 arc minutes of refraction, instead of using all of that, you're just going to use 11 of it.
Oh, but like the flat Earth number is off by 2 degrees, or sorry, 2 arc minutes, 1.29 arc seconds or whatever. The globe one there with refraction is off by 1 arc minute, 12.9 arc seconds. So like substantially closer. About 2/3 of the
So listen though, if that hypothesis were true and the star were being geometrically lower, but it was refracting over the peak, then the true position of the star would have to get lower with respect to the peak to further compensate for that last 1 arc minute of refraction. So it would still be above the peak. And then also, in addition to that, 1 second, people want to use terrestrial refraction as well to raise the elevation of the peak, but there's no convergent light source there. Like, that's not where the lines actually converge. It's just where they appear to converge. So what would actually happen if the refraction was lifting it up like that is the star would be visible inside of the top of the peak for like another 7 seconds, and that doesn't happen either. So I'm not concerned with after the fact corrections to say that the
my point is, like,
really here.
Every experiment has experimental errors. Like, nothing is ever dead perfect in the real world. You're looking at one model that's off by 11 seconds, one that's off by 7 seconds.
Yeah, and we're closer every single time.
Except for the one we're looking at right now.
Literally every single time. You would still be geometrically over it with refraction.
But I mean, it's a 7-second error versus an 11-second error. That's closer to the globe.
Buddy, it's not an error in that regard. This is the saying that the refraction is geometrically lifting it up over. So like if this were Earth curve instead of a mountain, as long as you could see the star, you would say that's how much refraction there was to lift it up. But because there's a mountain peak cutting it short, you're now just saying that, oh, it just matches, and now it's measurement error. That's not measurement error. It has actual. It's stated that it's mechanically lifted up geometrically over that peak still. So that's not a measurement error. That's literally the geometric prediction of the difference in intersections at that time, where it's going to take 7 more seconds to get lower, but it already got occluded.
I mean,
so now you're
using the same argument for the flat, it should have been in the mountain for 11 seconds, but you can still see it. Like, the flat has the same problem. You're not holding it to the same standard.
We're holding it to the exact same standard, bro. We're talking geometric intersections. You're comparing our geometric intersection difference to an apparent position intersection difference, when the true geometric position intersection with respect to the peak was 11 arc minutes off, totaling. That's a 1 minute difference, bro, in timing.
Okay, but remember, the globe doesn't predict you'll see the geometric. It predicts you'll see the refracted. So under globe theory, the difference between your observation and the globe theory refracted, as globe theory calls for, prediction is 7 seconds. The difference between flat geometric and flat geometric, which is what you're calling for, versus observed, is 11 seconds. So what we're calling for is 7 seconds off. What you're calling for is 11 seconds off.
Listen, and I don't. Yeah, we are every time, because we're doing raw.
You're not that time.
Not the one we're looking at.
What we're looking at is not. Is not.
Hey, guy, are you gonna interrupt me as I'm replying to this guy to chime in? 1 second, Zanuck. So this is a raw geometric intersection. If we were to add corrections to ours as well for refraction, we would also make ours match. The point is to compare geometric intersections. And if you go off the apparent, right, you would actually be over, and you would still have to wait 7 more seconds. If it took 7 more seconds for it to occlude, that would actually be decent globe evidence to support what you're saying right now.
Okay.
But it doesn't. In every single time, it's off.
And let me just
It's
get down to
always
this, because I think
geometrically
this might illustrate. Your assertion in this whole process, your whole argument here, is that in your model of how the flat Earth should operate, we would see the geometric occlusion and not the refracted occlusion. Your model
No,
expects the
that's not-
geometric, correct?
It's not my position at all. I'm saying using the geometric positions, we can predict the optical occlusion and the time at which the occlusion happens. That will form a congruent triangle from the observer to the mountain peak, and then from the mountain peak to the star with true positions using the intersections. We're not saying that you're going to see something differently.
So if we took your model and said, here is different mountain, we haven't measured it yet, give me your best prediction, the best you can do as to what the flat Earth predicts we would see as the occlusion time. Is that number using the same calculation method you'd use, or would you give that person a different number, like a different algorithm?
What?
Say I'm, measuring mountain.
We need the rise over run to the peak.
Yeah. But if I was
So
saying,
the
okay, here's the
elevation
setup,
and
I'm going to go
distance.
measure it tonight for this hill, this data, this far away, this height, whatever, this star. I give you all those numbers in advance. I say, predict for me what time it's going to occlude. Is that method on the green line using the same process you would give me if you were to say, this is my best guess?
Yes.
Okay.
Yes. Yes. And every time we're closer.
Oh, but the difference is the pink line isn't what I would give as our best guess. The white line, bluish white, whatever color that is, line
Yeah,
is.
called it.
Yeah,
Well,
but
I
this
give
isn't
it
the
a
cause. Listen, this isn't the cause of an occlusion, and this is cutting your refraction amount short to match our intersection. So, like, completely irrelevant if you want to use it. That's a completely different hypothesis. I just
You're saying if you ask a
it's-
Glober to give their
because-
best prediction with all the data given in advance, they would include refraction. They wouldn't ignore it.
and that doesn't cause the occlusion. So I'm not interested in
That's
that.
the fundamental
And
difference between our theories.
and also, being geometrically over it doesn't predict the occlusion. Like, so if
And
we go
again, that's
to-
the globe
so
wouldn't
if we-
predict.
hold on, dude. And then again, the globe wouldn't, dude, no. They invoke refraction 1-to-1 to lift up everything. And if they say that there's 23 arc minutes of refraction, then you need to use all 23 arc minutes. And when we do that here for this peak, now it's 2 arc minutes over, that's 30 seconds difference. So it should take 30 more seconds to set into that peak geometrically if it's being refracted over.
Sorry, what did you just change?
So-
Is that just wildly? Oh,
I just went to a different place because I told you
okay, yeah.
at different
Well, yeah,
places,
that-
it's different
that's
amounts
another
every time.
example. So on that
Minute-
one, the
minute
previous one you were
30.
showing, yeah. So that one you just
2
showed
minutes
12 seconds
40.
off for globe, 27 for flat. That one 15 seconds off for globe, 41 seconds off for flat.
7 seconds off for flat Earth. 20
No, I'm
seconds
talking
off for
the
globe.
column Q, delta time on the intersection. The time difference is 15 seconds for globe, 41 for flat.
That's 15 seconds of real time that it would take before it sets into
Yeah.
it.
Yeah, the time error is 15 seconds in our model and 41 seconds in yours.
But the occlusion happened at this time.
Yeah,
When these
but
when,
neither of them matches exactly, but the error is smaller for the globe model.
the globe model
I'm
isn't
using your
predicting
spreadsheet.
the
I'm not
cause of
even
the
calling
occlusion.
it.
Dude, I know. But this isn't the cause of the occlusion. We're doing raw geometric intersection differences. You guys
Again,
are 2
that's-
minutes off.
That is the fundamental difference between our theories. Is in your model it's a raw geometric, and in our model it's not. That's
No,
a
no.
big difference.
Buddy,
Halfway
if we
through, everyone
applied-
switched.
listen, buddy. If we applied a correction to ours, it would just match. It would be
You
the same.
said that was why I asked.
This-
If I gave you a number, would you use that same algorithm or would you use a different?
Yes,
You said that's your
yes,
best
because
algorithm. That's the closest. So that's
Joseph Formula.
buddy, the
Then you're
object
correct.
of the hold on a second here. The object here isn't to compare or after the fact corrections and see what we can do to make it match. It's comparing the geometric alignments. This is the purpose of it.
Well,
Wait,
the
what you're
actual
doing?
observation was the time. And
Yes,
our
the
model
time
predicts the
that
time
in
perfectly.
the time of that occlusion, we were 7 arc minutes in angular difference from our prediction, and you guys were 20 arc minutes from angular.
But that's the
position.
pink one is not what the globe calls for. The globe calls for the white line, not the pink line.
Sorry, dude. Are you making a geometric occlusion prediction off of the?
No, I'm making
positions?
an optical occlusion prediction. The thing you're actually measuring is optical, non-geometric.
Okay. Well, you predicted the wrong time then, because you actually need to add 15 seconds to this.
I
occlusion
agree.
time
We are
that
15
occurred
seconds
here.
off. The model is not perfect. Your model is 41 seconds off. Our error is smaller.
Listen,
Not perfect, but it's
listen,
smaller.
listen. You don't get to mechanistically cut your refraction off and then say, "Oh, my after the fact correction also happens to match the flat Earth, dude." That's
Dude,
preposterous.
I literally have not touched the spreadsheet. I'm looking at your calculations of our model.
I know.
Your calculations say our model has about a third the error of yours.
You're misinterpreting the data, sir.
Listen. If your hypothesis of this amount of refraction were true, then it would take 15 more seconds to set. So it's not valid.
Okay,
If
but
it did
your model
take
is 41
15,
seconds off.
if it
You're
did
over
take-
talking him. Can you steel man his position?
Alan's?
No, he's talking about refraction. Of course not.
Yeah,
Are
can you
you're
steel
stealing
man
Alan's,
Alan's
or Alan's stealing
position?
mine?
Can you steel man Alan's position?
Basically, my understanding of Alan's position is that by using the mountain peak, you are effectively able to ignore refraction. You can look at the occlusion time, and that gets you a pure geometric result rather than a refractory result. I disagree with him on this, but that is what he seems to be arguing. And because of that, you should be using pure geometric calculations. But
Well,
I think that may well be how it works in his flat Earth model, but it is not how it works in the globe model. So I think he's incorrect in using the pink row to represent the globe, and he should be using the white row instead.
Well, he explained why he's doing that, and you talk through him like mid explanation. So it's kind of like you're not listening to him. You're not trying to understand. That's how it's coming off.
Yeah.
I'll shut up for a minute if you'd like. That's fine.
Fantastic. So, to predict occultations or eclipses, etc., everything that we went through is based on geometric intersections of source and the occluding body. That is what we're doing in our comparison here. We're not saying that if you apply a second after the fact correction or what have you and chop off the exact amount to make the occlusion timing match perfectly, that it doesn't that it wouldn't be closer. That's retarded. At the time of occlusion, Flat Earth predicted this angle here. This was the angle of occlusion, or when it got occluded. This is the angular difference. This is what the globe predicted. This is the angular difference, right? The cause of what we see was predicted by flat Earth geometry. The fact that you could say that it works on a globe and what the globe predicts by chopping off your own refraction amount, that is exactly compensating for this central angle drop here, by twice as much almost. You don't get to just chop it off and say, hey, oh, look, it matches we're only 15 seconds off the occlusion time. No, you would have a completely different occlusion time. There's only one occlusion time, and it's based off of geometric intersections. We're closer every single time. That's all it is. It's that simple.
Didn't we all just agree the importance of the backbone of the globe model is the geometric intersection of the points and how it all works? And everyone was silent, no one disagreed, and now we're right back to, well, no, you can't do it.
Well, I may not have been here for that one or something, but yeah. So, okay. Yeah, like I guess you're using your model of this measures geometric intersections to judge the globe theory, which does not say that an optical measurement is geometric. That I think is your fundamental error here.
An occlusion is geometric, dude. Once we no longer see the star, we just need to know what time it was, and we can reference with accuracy of the globe model to determine the angle of the star to that observer and also to the end of that central angle, which happens to be where the mountain peak is.
I registered my objection. I don't think I've got much more value to add, so I'll let you continue in any other direction you care to go. But that's,
thank you.
Yeah, I hadn't realized that before. It's just kind of funny to me.
No problem. So, again, the importance of the backbone of all of this is geometric intersections. You could find this endlessly in different textbooks. I just took some excerpts out here, but I got a whole section on it here in Master Refraction. I think there's some in here where they talk about it all. So all the references can be found there regarding the geometric intersections, the cause of what is being seen. So the star's true position started at 233 for the observer, and it got occluded at an angle that makes a congruent triangle from star to peak to observer at 231. Oh, sorry, that's actually too far. My bad. At 233, sorry. So at the end of that central angle transit is when it got occluded. Now, whatever this air difference is here, could be refraction, could be how the coordinate system doesn't overlay with reality properly or whatever. But in any case, this central angle, or like this difference here, so 27 plus, or no, sorry, 20, I'm sorry, 7 minus 20 here for this globe's geometric intersection is 13. And that always comes out to be what their central angle is, what they would predict as globe drop. So the prediction within any arc length on the so-called globe, we can predict the geometric intersection that will cause a star to be occluded more accurately than the globe using the geometric intersection. Using the apparent positions, their amount of astronomical refraction prescribed to them puts them geometrically over the star, meaning that the time of occlusion should occur later. But it occurred when the geometric intersection was close to the flat prediction, because that's the end of the central angle. That's as much time, that's as much as you get. If refraction were mechanistically viably lifting things over a curve like that, then it would have to exceed that central angle. They would have to exceed that 50.5 kilometers to get lower for the observer to actually make that match for what the globe predicts. An occlusion 7 seconds later would be good evidence that that refraction works the way that they say it does.
When you're saying that refraction didn't fix it all the way, are you trying to say that it isn't perfectly predicted to be 0 seconds off, that it's 7 seconds off still? Is this what you mean? Or do you mean something else?
I mean that if you say that there's a specific value of refraction attributed to why the star is at a specific angular position, then that full amount of refraction has to be used up for a geometric intersection where it would be occluded. If you use anything less than that, then you're cutting that amount short just to match the occlusion timing.
I'm confused where
Because-
geometry comes to this, comes in play to this, because refraction is an optical phenomenon. But if you want to say, if this is what you wanted to say, that you have to use the entire value of refraction that you predict for a given time, then yes, I do agree with this. You can't just cut it, like use less or more than the amount you predict. You have to use the entire amount. If this is what you meant, then I agree with this. But maybe you meant something else. I don't know. You can maybe clarify.
Well, I've been over it several times with you, so I want you to write this one down so that I don't have to repeat it. Are you ready?
I mean, this will be saved, right, as a presentation on YouTube, so you don't have to.
Yeah,
Yeah, you don't
say
have to
that,
listen or
but
look
this
at
is-
stuff.
but
That's Embo.
this is going to be the third or fourth time now. So I just want to make sure that you specifically have the answer to it. So you have a pen and paper ready.
Yeah, I actually have.
Fantastic. All right. What was your question again?
Well, my question was, when you said that you have to use
yes.
the
Yes, it was about
Okay.
the amount of refraction. Yes. So if they're saying that there's 12 arc minutes of refraction, then the star should be at like 203 instead of 206 relative to the observer, because it has to get down that last arc minute and 12 arc seconds of refraction. Although I wouldn't even count the arc seconds, it would just the arc minute is the important. 12 arc seconds isn't a lot. But in any case, it has to use that full amount. It can't be just cut off arbitrarily to match, just to say like, oh, it just, well, it wasn't this much. It was actually 4 less, it has to be the equal amount lower than the object occluding it. Because for every instance where there's an observation like, Mount Canigou or anywhere, or like the Novaya-Zemlya effect, they say that, whatever amount of refraction is needed to explain it, that's how much was there. So that's a 1-to-1 relationship. So to say that there's 12 arc minutes of refraction here, then the star would have to be, its true position would have to be 12 arc minutes below the peak. Well, this is almost 13 because it's 1242. That's pretty close to 13. So, but anyway, it would have to be around that range, not a full arc minute lower, because that's 7 seconds of transit time. So it's above it still.
Oh, no, I get what I mean. Yeah, it would have to basically be that amount of refraction lower than the peak, because the peak is the moment of intersection. So this difference, it boils down to the fact that for the peak, use the geometric location of the peak, but the peak is also refracted by its own amount. Basically, it's just this.
Great. Yeah, great, dude. I'm so glad that you agree with the geometric intersection part. Now we can focus on the apparent position. So I have down here added the terrestrial refraction. It is geometric globe plus standard refraction. Now I do have these, but the reason that I don't consider them and will not consider them at all is because an apparent image is a virtual image. That's where light rays appear to converge. There's no actual light rays converging there. They will never cause interference with light rays that are interacting with them, because there's nothing there. So the apparent, altitude of the mountain that is increased by 2 arc minutes for terrestrial refraction plays no role in the occlusion or the in that mechanistic. And like I was talking about earlier, if there was a 2 arc minute apparent image of the mountain, then the star would set into that apparent image because there's nothing to occlude it. So you would have a star inside of the mountain at the time of occlusion, and you would still have to have the geometric intersection threshold crossed. That's why I include the geometric intersection threshold for the astronomic refraction position, because I'm willing to entertain the astronomic refraction bit, but the occlusion has to be physical. So I use the geometric intersection point for that.
The cause of the occlusion is physical, but we were talking about the location at which we see the occlusion. In order to convert the angle to the time, you use the angle as the reference, and the angle is optical. But
no one's measuring an angle here. All we're looking at is a star being occluded and referencing true positions. So rise over run to the peak is just what the math is for that. Like that's, no one measured that with the thing. Like if you got a theodolite out, that would measure like 219 or something like that, 218, 219. We're not saying that the optical angle wouldn't be that. We don't care about the optical angle. We care about the geometric intersections, because that's what causes the occlusion.
Yeah, but it causing the occlusion isn't the same thing as you observing the occlusion in its geometric place.
Yeah,
one doesn't logically follow from another. Like, I don't know.
Correct, and that's why our spreadsheet compares geometric intersections and not apparent positions. I just included this for you guys because you guys like to say, all these claims about how we don't account for refraction, etc. We do explicitly, but no, I agree, and that's why the spreadsheet is divided up into 2 sections here for the intersection difference for what flat Earth predicts versus what globe predicts. For the geometric, the apparent could be whatever the fuck we want it to be, with after the fact corrections and saying the star is here and there. That doesn't matter. We're doing raw geometric intersections.
I mean, it really cannot be whatever you want. I heavily disagree with that, but okay, like, I already told you everything I wanted to, and that was kind of my point, that like all of the objections that you could have, that you can make, were already told to you, so it's really just pointless to repeat ourselves.
It is especially pointless to repeat yourselves, and here's why. Because we open up most of our presentations here with this, because you guys like to say that about the refraction position, increasing the elevation, and you guys to date have never provided a single demonstration of a virtual image occluding light, ever. It's never, you guys never do it. So it's really weird that you show up with the same physical talking point, but no actual demonstration of a virtual image occluding light.
Nobody's saying a virtual image occludes light. It's a physical mountain. It's just the question is where the light is and where the mountain is when the occlusion happens.
Buddy, they're actually, I don't know if you're like haven't been paying attention, but they're saying that the mountain has 2 arc minutes of elevation added to it geometrically. So 217 plus 2 arc minutes of actual physical elevation to cause an occlusion because it would be refracted up by 2 arc minutes. The refracted amount that's being added onto the 217 is an apparent image. It can't occlude light.
Okay, you don't understand.
No.
Yeah.
I understand it very well. We have a mountain peak that's at 217, and we have an apparent image that's being added onto it that's 2 minutes of terrestrial refraction. So the mountain peak appears to be at 219, 218, something around there. But that 2 arc minutes that's being added to it isn't physical. You wouldn't say that the physical angle to the mountain is 219. It's categorized specifically as a different thing. And on top of that, an apparent image is a virtual image. Virtual images don't have light rays that converge from them. It's an apparent thing. It looks like that. So there's nothing actually there to interfere with rays that are coming in from behind it. So if you have a star setting from above it into an apparent image that you're looking at, there's nothing that it's interacting with physically. So you're going to see it go through it. And I actually have a demonstration of that I show right here. So I'm looking through a window. It's at nighttime. You can see the reflection of the hallway in the window. There's a light source outside here. I'm going to try and use the apparent beam to block the light. It doesn't happen. Let's take a look. All right, a quick lesson on the principles of the CEL-THEO. So what we're looking at here is you can see the pattern of that light is distinctly different from the lights that are in this hallway here that are being reflected out into the mirrors or windows there. But what you'll notice here is that the reflected beam, so like this right here, gets reflected out into the images, and as we move over, we can see that when we intersect the reflected image, it doesn't block the light. The direct light source is right there, doesn't get affected when we move into the reflected images, right? The only thing that actually blocks that light is the physical object. We must overcome that to see the light again. Okay, so what we're looking at here as we move, you see. All right, so an apparent image has no bearing on this analysis at all. That's my position.
It's actually quite funny. I mean, this is not really analogous because it's reflection, not refraction entirely, but it's still a little bit funny that even in that apparent image, like other parts of this apparent image are obstructed by other parts of this apparent image that are like closer than the further one. Like ones like the frames of this window that are in this apparent image, they are blocking the apparent windows that seem to be behind it. Like they aren't actually behind it, but that apparent image that depicts something that's behind it.
It's reflecting this outward from my perspective.
Yeah, but like different parts of this apparent image, they seem to be obstructing one another. The ones that depict the closer object seems to be obstructing the ones that depict the further objects.
So did you happen to see that light source get occluded by the apparent beam, yes or no?
Light source gets what?
Yeah,
what is this supposed to be an analogy to?
Dude, a virtual image, right? Reflected or refracted is a virtual image. It's an apparent image where light rays appear to converge from, but they don't actually. So this is analogous in the sense that a virtual image has non-convergent light rays. And what we have here is a street light outside, and it's not occluding the beam here, which is a reflected image, which this is a virtual image. Light rays appear to converge from here, but they in fact do not. The light rays coming from the street lamp outside are not interacting with anything here because there's nothing there to actually interfere with.
It's because it's in front of the pillar.
It's in front of the pillar. It's a virtual image. That's why. Now it's in
front of the pillar.
Buddy, the pillar is right next to me. This right here. Right here. The pillar is right next to me. You're looking at an image reflected into the window. Here. The light source is outside. This is a series of reflected images. So anyway, the light source, not occluded by virtual images because no light rays converge there. If anyone has a demonstration of an apparent image occluding a light source, that would be super welcome. And we've all seen this one as well, where the light source shows up in the apparent knife because the apparent knife doesn't cause.
Let's stop there for a second. Can we stop there for a second, Alan?
Yeah.
Go back to that.
Sorry,
lost it. Yeah, I just clicked on the wrong thing here. How to get back to your thing? Jesus Christ. Discord. Click on the wrong
But
button.
why are you trying to find it? So, Ellen, you're looking like right in front of you, just in front of your hand. There is a window.
Yeah,
or a
you
mirror.
have
Is that right?
not that one. The one with the
Yes, it's
knife
window.
through the water, cup of water.
Hang on 1 second, Zanuck. Let me get through Roundhound real quick.
Using it as an example, we saw that before.
Yes.
Yeah, there we go. So you're showing that we're looking at something that is being refracted through one layer of glass and water, and you're comparing it to something that's going through two layers of glass and the water behind the knife.
Yes, we are comparing a virtual image that is inside of the glass to the real knife that is also
Right.
inside of the glass. And
But
when
look
the
what
light
you-
source is intersecting with the apparent image, you can see the light inside of the knife. And when the light crosses the actual knife, it's no longer visible.
And where's the light source coming from?
Taylor's hand, she's holding a laser
Right.
and she's moving.
Is the
it.
knife
The light in the room. Is that what
is
you
the
mean?
yeah no
Guys,
is the
guys.
laser going through two layers of glass while the knife is going through one layer of glass? Yes or no?
It's only going through one
Okay.
layer.
So
of
would
glass.
that affect the position of that light? Why would the refracted image of the knife not be affected by not affect the light beam? Because the light beam is actually being refracted twice.
Because no light rays converge from the apparent knife. They appear to converge from it. There's nothing there to physically interfere with them. You're overthinking the situation with the glass and all that. All this is if there's an apparent image, the light source will not be occluded by it. That's it. Just you can think of any example you want. It doesn't occlude it.
The laser isn't the light that's causing the refraction. The room, the ambient light in the room is what's causing the refraction.
No, the light
That
the,
doesn't sound right to me.
Buddy,
the
it's
glass
a
is
laser
causing
pointer.
refraction.
It's like
The
Yeah.
glass is causing refraction.
I know the glass is causing refraction. Sorry, but we see it. We see it because of the light in the room. The laser is a different light source. I don't think it's a valid observation, to be honest.
listen, great. Can you do me a favor and show me a virtual image including a light source? If mine aren't good
Yeah.
enough, guys, just
Yeah.
show me a virtual image including a light source.
All you gotta do is look at that the propane dropped on that container that blocks a red light that's below it, and when you see me drop the very
Oh.
cold,
Oh, I got you.
right? That is your why is the laser now rising up and now not being occluded, whereas before it was occluded because it looms up due to the variance in density and the angle of incidence.
All right.
This
All right.
Go back a little bit.
Yeah. 1 second. Zanuck, I need you specifically to watch this in its entirety when you get a chance. It's a really fantastic video on refraction and this exactly. But yeah, we're going to show you here exactly what's going on. So there's a difference between a geometric occlusion, like something being actually blocked, versus an optical occlusion. So in the example for the propane tank here, where is it? Give me 1 second, trying to find it. Bear with me, lads.
What exactly is the contention? They think that virtual objects block light now? Is that
Yeah.
No, the light path
No,
path of the
1
light
second.
is changing due to refraction. That's
One
what's
second.
in contention.
1 second.
it didn't answer my question?
Yeah, no one's contending that light can, be bent and change directions and shit when you introduce a different medium and all that. But what he said specifically was that there's a geometric occlusion here, and that when a different medium is added, the light ray goes over it. So why isn't it blocked? Now, what he referenced wasn't even analogous to what's being discussed, but we're going to go ahead and break it down anyway. So in this example with the propane tank, what we have here is this can with some Play-Doh on it. This red Play-Doh and this blue Play-Doh are geometrically above. When you watch the video, they're geometrically above this container here. And this camera has been lowered so that it just happens to align optically with the container and the red Play-Doh. But keep in mind that behind that object, and it's not even attached to it at an angle, mind you, it's fucking just behind it, but higher in elevation than it, right? When he adds the second medium, let me see if I can play it out from here. When he adds the second medium here, the light rays get bent up a little bit and you can see it, but there's no geometric occlusion here. Now, what Vanby did, and here's the timestamp for this specifically, guys. Highly recommend you guys watch this. So
Wait, is there a geometric occlusion of the red Play-Doh right now before you start the video?
Optical.
Would you agree there's not a geometric occlusion right now?
It's optically occluded.
Why would you say
because the red? I'm going to show you the distinction here in a second. Let me continue. So the elevation of that red, it's actually physically over the tank, but for the observer on the other side, it's optically being blocked at this side. So there are light rays that are coming out over extending that aren't visible because it's being optically obstructed from this. But this isn't geometrically lower than it. Now hold on. Just Zanuck, for the love of God.
I'm not saying anything.
No, that was me.
Oh, I'm sorry. I could hear you starting to cue it up. It was Roundhound. Just settle down for a second because this is extremely important, guys. You have
I'm
to
totally settled.
You have to follow this. Thank you, Zanuck. I appreciate that. I apologize. Thought it was you. So when he adds the liquid there, the red Play-Doh does appear, and I'll see if there we go. Perfect frame. So there it is. Now keep in mind, its elevation is physically higher than this tank, and that's going to be extremely significant when Vanby does a follow-up demonstration here. So this is a side diagram what it looks like here. The occlusion here, it's being optically blocked, but relative to this, it's still geometrically above it. So what Vanby does in his rendition of it, oops, 1 second. Okay. So he has the object doing the occluding, and it's geometrically higher than the light source he's trying to refract up. Here's our observer elevation. Here's the setup. And when he adds the medium, nothing happens. It doesn't geometrically lift back over it. So there's a big difference in what's being talked about there. Now, secondly, Zanuck, what was being discussed specifically, and why this isn't even analogous, but I humored it anyway because my boy Vanby just absolutely crushed this. Why this isn't analogous here is that they're saying that this container is actually lifted up a little bit and it's blocking it because of a virtual image. Putting a medium on top of that behind it and then having the light rays bend is nothing to do with what we're talking about. We're talking about light rays not appearing to converge from a source, but they're not actually doing it because it's a virtual image, it's an apparent image. So it has no power of occlusion because it can't interact with the actual light rays. That's all it is. This is not analogous at all.
It's not a virtual image. It's anything that you see, the light has had to travel from it to your eye. So as far as your eye is concerned, that is where the physical object is, and the light that's being occluded by it has to travel the same path to get to you.
Negative, Ghost.
Has anyone ever seen a star through a mountain?
Exactly. That's exactly my point. They're saying that the mountain is being lifted up virtually by 2 arc minutes, by an apparent image. It appears to be a little higher by 2 arc minutes. There's nothing that converges at that 2 arc minutes that's being lifted up. It's apparent. I just gave, hold on a second.
The light of the star.
It's real important to understand that.
Has to travel the same path that the mountain does.
When I said that, you figured that just meant finish your thing really quickly? No. So what it meant is follow this through. This is not the same this is not analogous to what's being put forward. So this is a different scenario entirely, where this is elevated above the thing optically occluding it, adding the medium, bends the light ray that's already geometrically over it, but for the observer, that's what makes the connection there to lift it. What's being said about an apparent image causing an occlusion would be if this container was refracted and was being lifted up, and then an object was being lowered, like a light source, and that light source got blocked while it was intersected with the apparent image of the container, not this image at all. You guys are conflating separate things here. We need to stay on task for the
Well, then you have to have...
You keep saying it's high though. Like just putting the camera down and putting the cam with the Play-Doh on it higher. This doesn't mean it's above the tank.
Yeah,
you just roll your image to the right slightly, and they're both level and slightly under the tank. You can't say it's above the tank.
Yeah, it's below the tank. The red is below the tank starting out. Hold on. Let me just say,
it's physically over the tank.
I'll let you talk for the whole time. Let me just say my point. So go back to the tank. You keep on saying things, and just saying it doesn't mean them true. The red area is below the tank. In your line of sight, it is blocking, it is obscuring the red area. It only becomes apparent when you pour liquid propane on the structure, which makes that medium much more denser near the surface, which in front of it and behind it, which bends the light down toward the denser medium, which obviously now looms up the red area Play-Doh because the light is bent just one area. It's not like the differential form of Snell's laws we talk about under the globe circumstances, where over a long distance, over the curvature of this curved medium, we have light continuously being bent downward, in almost infinitely small segments. We're talking about this one, that red thing is below the level. When nothing's being poured on.
How do you know it's below?
Yeah,
because they show it.
It's Zanuck. It's not. They don't show it. It's literally in the video, and you could see that.
Why don't you see it then? Why don't you see it?
It's optically obstructed. It's not geometrically obstructed.
How can you possibly say that?
Zanuck, because it's only optically obstructed relative to the observer being lower than the thing. This is geometrically over the object occluding it.
Right? Roll that image a little bit to the right. Roll that image to the right.
I'm about to roll your volume all the way down to the left so I can finish talking.
Yeah,
so
I'll just
what happens here is that the light is coming over. It's already being emitted out everywhere over top of this, right? It's already geometrically exceeding it. When you add the medium, it lifts it up, showing the virtual image of it. I'm not saying that's not possible. Shut up, please. I'm not saying that that's not possible. What I'm saying is that that's not causing a fucking occlusion. That's what we're talking about right now is not even analogous to the occlusion. We're actually off topic now.
No, we're talking about basic refraction. You
actually can't. So listen, what they're saying with the mountain being an apparent image would be the same like as saying that this barrel, right, is actually a little bigger because it's an apparent image of the barrel. So they're saying that the apparent image causes an occlusion. And I'm saying apparent images are virtual images, and that virtual images are where light rays appear to converge. They do not actually interfere with anything. They do not cause an occlusion. This is occluded because the observer here is geometrically under this object, but the thing that's about to be refracted over it isn't geometrically under the object either. That's why Vanby did the experiment where he measured it out and made sure it was under it and to see what would happen and whatnot, and it doesn't lift it up analogously. Now, real quick, stick to the actual point, because this is the only thing I actually care about. I could give a fuck about this, really. What I actually care about is that you guys are saying that this barrel would be like an apparent barrel, and it's actually higher in altitude, and it's causing light rays to be occluded from it. But we see from the apparent image here doesn't occlude light rays. We see the apparent image in this mirror doesn't occlude light rays. Apparent images are virtual images where light rays appear to converge. I'm almost done, Zanik. I know. But hear me out. So, no, you went to a different topic completely. I answered it thoroughly, showed you the differences, and now I'm trying to bring us back to the original point of the occlusions, which is right here. An apparent image never blocks the light source. Go ahead.
Okay, thanks. Go back to the barrel again. I mean, this is a very key point there. You're just missing the point that, yes, if that red area is not being seen, it is not being blocked optically because there's no refraction going on between that camera or the eye and that object. Now, if you wanted to really do this test properly and really make it more analogous to your contention, what I would do is do this test again and have something behind the green and the red Play-Doh, behind it, to the right of it. Maybe a laser, having it shining to the camera, and see if it then looms up and blocks the laser. And then that would then show our point, which shows that things that are loomed images, which are still real images. They're just your eye is only following the light emitted from those objects. And if light emitted from the objects has a curved path, then they will be loomed up or down, depending on whether the refraction bends the light down or upward. So my point is, if you really want to do that test properly, put something behind the clay thing, or do an experiment where something behind it. Go back to your knife one again. That is complete conflation of all the ideas of refraction, because you have a laser behind going through a layer of glass, then being refracted, then coming out of another layer of glass, which shows that the knife will not block that refracted light source, because the knife's only going through one layer of glass with respect to your eye. So it's a completely erroneous test. It doesn't really show anything other than the fact that you get more refraction going through two layers of glass than one layer of glass.
I maybe make this really simple.
I'm going to make it even more simpler, Aldous.
Sure.
The apparent knife never blocks the light source under any circumstances ever.
You can't say that. Put the laser inside the water and it will block it. Yes.
Oh, buddy. It only blocks it when it's geometrically intersected. And yeah, if you put it in, then it would be already bent. So when it geometrically crosses, it's not going to interact with it that way. But the purpose of this, right? This is a separate thing that you're conflating the two, right? This is a mountain peak that they're saying. Let me just use this. So they're saying this green circle here, right? They're saying that it's not 3.5 inches. It's actually 5 inches because it's an apparent image, right? So if you were lower,
light between the camera and the ball.
Listen, no,
I'm listening.
That's not what's happening. They're saying that this itself is refracted, not what's behind it. So pay attention. That this that this is refracted up. Okay.
Mm-hmm.
Now, when a light source is getting lower and lower and lower, when it interacts with the apparent image, it doesn't cause an occlusion for the observer, because there are no light rays that actually converge at that image. It's an apparent image. So when we look at the glass, it doesn't matter how many glasses or waters. The main point is that there's an apparent image in this glass, and it doesn't occlude the light until there's a physical intersection. And the same thing happens with the virtual image projected into this mirror. It doesn't matter the scenario. An apparent image is an apparent image. An apparent image means that there are no light rays that converge from it. Do you agree or disagree?
If it's apparent light rays,
there's a lot of confusion going. You can look at.
Do light rays converge from an apparent image, or do they appear to?
What does converge even mean in this context?
Yeah, I know. I don't understand the word.
Do they?
Oh, you two guys are ridiculous.
Do they?
It doesn't make any sense what you're saying.
Let me make this real simple.
It does make sense. Yo, real quick. Yo, guy that said you didn't understand it, real quick. So on the Imperial Japanese flag, you have a red dot in the middle, and you have a bunch of lines converging on the red dot. That's how light works with a source. The light converges onto the source in which it came from, the path of light. That's what's being spoken. It's not that complicated. Stop wasting everyone's time.
Thank you.
When I was trying to make literally 10 minutes.
No, stop.
If you look at the barrel experiment for a second.
Aldous.
I'd let you talk for like 10 minutes. Give me 30 seconds.
A better one.
Give me 30 seconds.
Is a virtual image where light rays.
Look at that barrel
I
experiment.
don't care.
That's not the presentation.
Listen, guys. Listen, it's not a democracy here. So Aldous, simple question. Is a virtual and or apparent image a place where light rays appear to converge from? Or do they actually converge there? Go ahead. Yes or no? It literally can't get any simpler.
Very alien to me, but I'm pretty sure they would still, if that's where the light's coming from, reaching your eye, that's where the light's coming from to reach your eye.
Incorrect.
You can't tell what path it took to get your eye. You can only tell what direction it's coming from.
It's not about telling which one. It's about physical intersections. If they appear to converge there, then
you're using physical intersections that appear together. Those are different things.
Oh my God, dude. buddy.
No,
that's our fucking premise. That's what we started
jump
with.
between physical and apparent and treat them like they're the same thing. They're not.
Aldous. No one's jumping between physical and apparent. That's literally you guys' position.
You just said it
that
appears
apparent positions occlude objects. A virtual image. Real images are those where light rays converge, whereas virtual images are locations from where light appears to have converged. So, simple question. Is an apparent and or virtual image a place where light rays converge? Go ahead.
And you say it appears to converge.
That's because that's what makes the apparent position. That's what makes it apparent.
Well, yeah, but that's all you can measure. Like, unless you
that
do
doesn't listen. It doesn't,
non-optical, that's all you can measure.
Guy, it doesn't.
Did the oil rigs block Catalina?
Listen, guy. Asking something completely separate, Zanuck. Try and stay focused here, man.
That is focused.
So listen, Aldous. A virtual image can't cause an occlusion though, because there's no rays that actually converge there. So there's going to be no interference.
So is your argument then that occlusions must be geometric? Are you saying that occlusions are
100%? That's my.
Okay.
That's.
And this is where we're going with that barrel experiment. If in that barrel experiment, the camera doesn't move, the objects don't move. 1 minute it's occluded, 1 minute it's not occluded. Nothing physically moved. So either they were, I don't even know which it was. It may have been that they were geometrically not occluded the whole time. Maybe they were geometrically occluded the whole time. But the refraction changed it. It went from one to the other. So it cannot be purely geometric because the geometry didn't change, but the image changed.
Correct.
Occlusion changed without the geometry changing. So occlusions can't be purely geometric.
Here's why here's where you're confused and wrong. Right? This barrel is the geometric thing blocking, right? Lifting a light ray from behind the object is not in contention. That's an effect that we all just witnessed and saw, right? We're saying that this barrel, if you were to add some height to it for apparent size, like if there was some refraction here that was actually lifting the barrel up to make it appear to be a bigger size, that wouldn't, and if you were to like lower a laser behind it, that the laser would not be occluded in the virtual image because that's where light rays appear to converge. But lifting light rays, please do not make another unanalogous scenario again. I can't do it again. So adding a medium to this is not, and lifting it up is not what's in contention here. And on top of that, the occlusion actually is geometric because when the elevation of this object that's behind this object is actually lower than the object occluding it, then you can never get it to lift up. That's what Van Bee's whole presentation and experiments were done, or what his measurements were all done. So it doesn't even work that way. Where this is lower, pour this on it. No, it doesn't. Bro, go watch the fucking video. It's literally higher than the barrel. You guys are all saying that it's lower. You guys are all sadly mistaken. Van Bee, can you come here?
It doesn't even matter which it is.
No, it matters specifically because when it's lower, it doesn't actually lift up because it's geometrically occluded. Occlusions are geometric. Ta-da! But anyway, a virtual image of that barrel wouldn't occlude anything. That's it. Okay, lifting an object over it with refraction isn't the barrel occluding it, guy.
Because not
light rays are appearing to okay, dude, that's actually perfect. Okay, Aldous. The light rays in the barrel scenario, when they get lifted up here, right? They're appearing to converge here. But we know when there's no medium force on between here that the light rays don't converge from there and there is no apparent image there. If you were to introduce a laser or something to this red thing, it wouldn't be occluded by the red because it's an apparent image.
Once you get a laser, dude, that's a great test.
Barrel here is what's occluding.
If they had that thing,
good test. Yeah, I don't think it would work the way you're claiming.
Yeah, I don't think so either. I think if you had a laser pointing at the camera directly behind it, hold on, and everything was flush.
And it didn't work that way. And he even did analogous to a globe where he had an object fixed on the object that was rolling away from it, so it would be angled away, and that didn't produce any emergences either when it's physically at a different elevation relative to the thing occluding it. So
yeah.
And you guys are making the claim here. Why don't you have demonstrations of a virtual image blocking and obstructing an object?
Great request. Great question. CEL-THEO and I both think that if the laser is pointed at that barrel behind the red area, maybe it chopped off the green area and just had the red hidden. And hold on, and he had a laser just skimming the top of the barrel.
We've been going for an hour and a half, and now we're on virtual images and occlusions, a subject we will focus on for next week. So everyone, for next week, bring your best demonstrations of virtual images occluding light sources. Now, I got Bull Knight, who's going to be getting his tank next week, so he's going to try and do some stuff to quantify the occlusion of a light source and all that with respect to a physical object in the tank and all that. So we'll be able to put some numbers and stuff to it. But you guys, if your position is that the apparent position of a mountain, which as we just read, I have a website here, right, where I take all these clips of explanations of what a virtual image is and an apparent image and how light rays don't converge, et cetera, and I just read from it. So we all know that if there's nothing there to interact with it and it just appears that way, it definitely can't cause an occlusion. So if the mountain is being geometrically lifted up by 2 arc minutes, that 2 arc minutes is going to not actually occlude the light, and the light is going to be visible inside of that 2 arc minutes of the peak. But as was pointed out earlier, it doesn't happen. It gets occluded, basically as soon as it goes into it. Rob, if you're there, do you you have some questions or something?
Alan, I've been waiting like 2 weeks. I could probably talk about this with a lot of people, but you seem to be doing a lot of star stuff. And my question is kind of simple, but do you think you can pull up that picture you had with the globe with the happy face on it? Like it was like your first image, yeah. So let's say you're just a human being standing on the top of that water ball, and then you've got your celestial, not the celestial, but the equatorial plane, right? You're the little dude standing on the top, and then you have the equator about 39, 59 miles below you, right?
Yep.
How are we seeing the stars 180 degrees apart from each other on the equatorial plane if we're the little guy on the top of the dome? Like, how
Our
do we see
vision
those
of
stars? Like, I don't
yeah,
understand how we even see 180 degrees of the sky.
yeah, our vision is basically an entire hemisphere. You can think of it like, so if you were at the equator, Polaris would be at 0 degrees. So all they've done is just map out the lengths at which you can see something, and then that, when you move away from it, how it changes angularly. And they did it within a specific band, a specific optical band. I think from like 30 degrees to 70 degrees, there's a linear relationship where it's pretty close to 60 nautical miles per degree, and that's the base of it. So all they did was just take how we see naturally and kind of turn it into a coordinate system by taking the linear portion of it and making it symmetrical, and then mapping stars to and deviations
Yeah,
from it.
it's so weird because you just brought up the putting somebody on the equator. Like, technically, we go 90 degrees from that. Somebody on the equator, technically, shouldn't they be able to see Polaris and the Southern Cross at the same time?
I don't think so. I'm not for sure on the Southern Cross
Well,
thing.
if you look at the diagram, like
Believe it or not, you can see both at the same time. I think there are probably some photos of it. They're both very close to the horizon, obviously, but I think it's possible.
No, the Southern Cross is 20, 30 degrees away from center rotation.
Yeah, sorry, then Sigma Octantis, whatever that southern star is. I think it's possible to see both.
Whatever the closest South Pole star would be is kind of what I'm getting at then, I guess. I don't know. Is there a globe explanation?
Yeah, it would be possible to see both of them at the same time. If there was, if they aren't perfectly in the center of the poles, but let's just assume they are for simplification. In that case, they would be perfectly on the line of the horizon. So the horizon would be basically cutting through the center of them. If you were at the sea level, but because the horizon drops with altitude, if you went enough high, the horizon would drop enough to reveal the image of what is actually slightly below the horizon, below the horizontal. So you would be able to see them from some higher altitude due to the horizon drop.
And you also get about an extra, half a degree from refraction. It's basically the same thing as the Selenelian eclipse, just with north-south instead of sun-moon.
It's basically the same thing.
Yeah, I don't think the Alan's picture really lets you understand the scale of how small we are, really, right? And for you to think that your tiny little person, oh, the image is gone. Your tiny little person that's on that sphere earlier, like, I don't see how he could see below him. Do you know what I mean?
You don't.
Like,
it's not below you. You just see to the.
It is though, because if you're on the top of that, that's perfect picture you got up right now. If you're on the top of that ball, the equator is 39.59 below you, right? And that plane, how are you seeing anything on that plane when you're like the tiniest little dot on that ball? You think you're seeing 39.59 below you, way the fuck out there?
Yes, that's specifically exactly what they mapped it to for that.
The celestial equator is not the same thing as the equator on the Earth. You're not seeing people standing on the equator on the Earth. Those countries that are on the equator, you're seeing the stars. That's
Embo is not even what.
Yeah, no, it's not.
That's not even what he's talking about.
Then why did he say something?
Why is it that you always try to answer something and it's literally never related to what was just?
Never look, never know. Don't have to.
That's so crazy. You just said an entire thing that was absolutely unrelated to what he said.
Yeah, I don't even know if he could feel, man, what I'm talking about.
That's crazy.
Because he said something about being
all they're
3959.
in the hemisphere of vision, all they're doing is saying that the reason that the stars are changing place angularly is because of the ball, right? It's not that they're seeing around the side of the ball. They're saying that what you see horizontally outward from you is changing physically because of ball, because of that relationship to the equator from your position.
Yeah, just because you'd have to. It's just so weird to me how the ball works and the sky works, and we see apparently we see 180 degrees of the sky, but we would have to look down 39.59 to see out.
Nah,
that far.
So instead of looking down, right, because their stars are still above you either way, it's their angular change. It's the reason that they're that low in the horizon versus being at your 90 because of that relationship. It's not, you're not looking down at them. You're always looking horizontally. All they did was take the curve of the sky and then just say that you're standing on the exact same curve, essentially. And that's why you see it that way. That's all it is. I don't know.
Yeah, that's so weird. I understand what you're saying, Alan. When I think that I'm on the top of the ball, I don't understand how I'd be able to see 180 degrees of the equator celestial sphere.
Oh, I think I kind of I think I understand, because if you were to draw some kind of star to the scale on this diagram, like the ones that are here, and Alan rotates them in his presentations, then they are very close to the Earth. So you can imagine that if you place this star, let's say, above the North Pole, then the person standing on the equator wouldn't be able to see that star due to the curvature getting in the way. But the stars are basically so far away that they are pretty much infinitely far away. So that means that angle wouldn't.
We're gonna go ahead and wrap up for this one. So
yeah, thank you, Alan. That does help me. Thank you. I appreciate it.
No worries, lad. So for next week, we're going to do we're going to focus in on apparent images and occlusion. So like I said, bring your best citations and demonstrations or examples, etc., to prove your point, and we'll go over them meticulously. But as it stands, Embo, special shout out to you. You did agree about the refraction amount being having to fully be considered. So that's awesome, and I completely agree with that position. And again, our position is the raw geometric intersections, not considering after the effect corrections or making adjustments or whatever. Just the raw plain trig to it makes the correct prediction in every single scenario. And the difference why the elevations are off when you derive the triangle is based off of the intersection difference at the time of occlusion. So that's the root cause of it for both flat earth and go to derive elevations. Awesome session, everyone.
Half of what? Because I don't remember agreeing to half of anything. I don't remember ever saying the word half.
That's all.
Yeah, but it's like, I mean, I appreciate that, but I feel like he's going to misunderstood what I agreed to, and he's going to use that in the next presentation to say that I changed my position. I think this is what's going to happen.
Oh no, I would never think you changed your position. Don't worry about that, Embo.
We would all know he instantly lies, because that would mean that you read, paid attention, and learned something or whatever.
Yeah, no, I didn't change your position. My position was that if you're 12 arc minutes above, or if there's 12 arc minutes of refraction, that the object or the source would have to be 12 arc minutes below it to be occluded, and not like, for instance, 10 arc minutes or 11. And you said you agree, and there's nothing wrong with agreeing with that, because that is the backbone of what the globe says and how it makes refraction work. You're just the only one who's said it out loud so far. I just was giving you props for saying that.
I do agree with that, but still, where's the half in that? Because you said something about the half, and that really confused me.
Where's the what?
The half, like a half of something, the 1 divided by 2. You said the word half.
I'm not sure. I don't know.
Maybe you were only half listening.
The half? Are you saying the half?
Yeah, that's at least what I heard at the end.
Yeah, I'm not sure. But anyway, see you guys next Monday. Thank you.
Thank you, Alan and Shane.
Sorry, things got a little heated as always. Things start popping off, and then
it wouldn't be very much fun if it didn't.
Yeah, but no hard feelings, lads. Appreciate you all for participating. Thank you. See you guys next week.
I
mean, for what it's worth, I will say that you guys are the least obnoxious flat earthers I know. Like, you can actually have a mathematical discussion, and you're wrong, but you're wrong in a way that isn't totally dumb.
So that puts condescension. It's nice. That makes us feel warm and fuzzy. Also, I'm super concerned with your opinion.
That's totally disrespectful. Well, I know you're wrong.
You're doing a good job, but you're wrong. I know you're wrong. I don't have to know why or look at it, but I can just tell you're wrong based on your position.
I mean, my GPS device says you're wrong, and it works. So
yeah, so we can just spam fallacies and red herrings and change the topics and do the normal tactics as always, if you like.
I mean, there's a lot more than one piece of evidence about the shape of the Earth. The celestial theodolite, it's not like we were ignorant of how the world looked before this thing came along less than a year ago. We've known.
We were ignorant of ways to compare models without the obscuration layer of refraction being a save-all and applied as a retroactive curve fit after the fact. Now, when you have to use it to predict things, it's not enough and wrong. That's the difference.
Well, we don't do it after the fact. You can use, we use standard refraction. This is why I found it so interesting that Alan's model was the one I could use to show that the globe was closer, because he's not going in after the fact to try to save the globe one. We can pretty sure that he's not on the globe side. So if his numbers, they're not cherry picked, they're just going to be standard refraction, are showing the globe is 4 times more accurate, then the globe's probably 4 times more accurate.
If your globe is so accurate, can you tell me what the refraction is going to be tomorrow?
Personally, I don't know the math for exactly how to convert weather figures to it. It can be figured out. I can give you an approximate number
each and every time.
Well, okay. But of course, there is a way to convert this is the weather to this is the refraction. Like it is a thing that can be calculated. It isn't just ad hoc, I picked a number. And honestly, even if you use no refraction, it'll be closer than flat Earth in most measurements. Not in CEL-THEO, I'll give them that. But for most measurements, no refraction globe is closer than flat Earth. And standard refraction globe is much closer than flat Earth. So, like even if you ignore, it can't explain mirages and stuff. But it can explain 98% of what you see. And it can explain 95% of what you see with no refraction at all.
I have a question. So, did you learn about flat Earth in 5th grade, like I did?
No, it was. I think I saw some people discussing like 2010, 2015, and just sort of it was one of the last few years. Started really thinking.
Cool. So, you learned about it. That's very interesting.
After the indoctrination camp.
Yeah.
What's interesting about it?
Okay, so when I heard about it, I actually did tests, experiments, things that people were doing online, and I tried to recreate them. Did you do any of those, or did you just rely on textbooks?
Neither. I started reasoning for things I could observe around me. Not so much I went out and bought a bunch of kit and did experiments as, satellite TV dishes always point in the same direction. GPS devices work. All this sort of stuff.
So you didn't do anything at all?
I know science. I can look at data.
I haven't. All right. I guess I have a degree in science. Cool.
Andrew, I don't. My degree is in economics, but I know science.
Don't forget about GPS, man.
Andrew, since we both have a little bit of engineering as a background and some physics, right? Like you said,
yep.
You know how refraction works. I gave you an example. Maybe you can conjure up something, because in our minds, people that have studied physics for many years understand. And this is in that area. I was not specialized in this when I was going through school or in my professional career. But it's physics. And once you learn how to learn, these concepts aren't hard to really grasp. So if we talk about things looming, like the oil rigs looming up, and we know that they block objects behind them. Alan's flat out denying that it can. He's getting very upset with us that we think that it's possible because they're quote virtual objects. Try to conjure up some kind of test like with the propane. I think it'd be pretty easy to do. I don't have any. I guess I do have propane here. Maybe I can do it. But I think I would guarantee that if you chop off that top green portion of the clay and just had the red where you couldn't see it at all, but a laser on top of it, right at the surface of that tank, looking down, as we all now know how it's set up because Geo posted the video, which is great. And I guarantee that pouring propane on that container, it'll loom up the red, and it will block that laser, and it will show.
It's liquid butane is what it's a propane tank that he uses, but it's liquid butane is what they actually pour.
Yeah, whatever it needs, kind of liquid nitrogen.
Not any kind of liquid. It's specifically butane, liquid butane.
Well, it can be any kind of frozen, any kind of cold liquid gas that is at a very cold temperature. All we care about is it being very cold. If it's very cold, it'll bend the light downward, and that is very cold. It's probably negative 250 or something.
Well, I'm just saying to replicate that one. I mean, you could try other gases and see what you get. I'm just saying to replicate that one. I'm just saying that's what he did.
Yeah, it wouldn't matter what gas we. I mean, the fact that all we're trying to do is show that if we do have something loom up, we know it will block the light. That is the contention. That's the hypothesis, because the light will be bending downward due to the differential medium being denser down. And so if it's butane or liquid nitrogen or liquid, anything, it's going to bend the light down. That little red thing will shoot up. It wouldn't be. We set up so it's hidden, and like they showed us, that the camera was below the propane tank, and the clay object was set up just so you could see the green on top and not the red. And when he kept on pouring that in high detail, pouring the propane or whatever it was, butane on the tank, it loomed up a 1/4 inch of that, that red clay. I'm saying lap off the green, have a laser behind it in the distance, maybe 10 feet behind it or something, and watch that laser disappear due to the looming of the red section above the green.
Okay, can we do this together?
Yeah, show it then. Show it then.
Oh, we would. I mean, I would bet money on it. Now, would you bet money that it wouldn't be hidden? That it wouldn't be hidden?
Well, I'm just saying. I mean, if I follow what you said there, that might be what Alan was referring to. That you would have to show. Although I'd have to make sure I understood exactly what you mean. But in terms of something that is claimed to be lifting up that is actually blocking, because that little clay thing with the tank as is doesn't show that, and that's what he was pointing out. So you've yet to show it or demonstrate. If you can, it sounded like he was open to seeing it. I think we're all open to seeing if anything can be, things can be demonstrated. So
well, we said,
do it.
We saw the red rise up. Obviously, the green didn't do anything because it's only happening. This refraction is happening very close to the surface. So it'd be critical to have this thing lapped off, just like they said. I would set up that exactly like they did in that video. Lap off the green clay. No green clay. Only the red clay below the tank, as your eye can see it, completely hidden. With we've tested, so it's just below the surface, so you definitely can't see it by the camera. Pour the butane. Have a laser behind it that's probably hitting about where the green clay was. It's not there anymore now. We have just a laser skimming the surface of that tank, and watch what happens with the. With the experiment, watch this virtual image. Watch that virtual image block the light. If that happens, then he's got to rethink his premise.
Is this an experiment that can be done once?
I think be done as many times as you want it to be done.
No, I mean once and done.
I think so. Yeah. I mean, I have a nitrous oxide bottle I used to use on the race car. I pull that out, and I wish it was filled with nitrous oxide because we could use that. But I'd rather pour liquid gas on.
I think I have some nitrous oxide.
It'd be nice to pour it on to have that same effect as we saw in the video. And then have a laser. I have a laser. Have it in a distance, pointed right at the camera.
Zanuck, you're telling us light is going to block light. That's what you're saying?
No, the object will be blocking light. The light is something.
No, the object is just the light. No, the object's not going to be blocking it. The light, the refracted light from the object is going to be blocking it.
That's the problem with your thinking. It's illogical to say that. Even though the light is what is bending. The path of the light now is taking a curved path down to the object, which is going to block the light. So yes, the object is still blocking the light.
The object is down low. The object's going to be refracted up. So it's just the light that's refracted up. And you're telling us that light is going to block another light. That's the problem with your thinking, is you think there's a problem with my thinking, but you think that's what's going to happen, right?
Yeah, because your eyeballs, the light that's going to your eyeball is going to have to bend around that tank, and it'll run into the physical object, which is the clay.
No, not the physical object, the refracted object. Not the physical object, the refracted object.
Right.
The light.
He's saying,
the light from the object, not the object.
I hear what you're saying. I totally understand what you're saying, Jeremy. So what you're saying and what he's saying is that the red thing will loom up, and we'll still see a faint dot of the laser through that virtual image. And that's what we disagree. I don't think that's going to happen.
That's why it seems like that's what would happen, just from everything I've seen and observed with lenses.
Can I jump in real quick and comment on a misconception I think Zanuck is making here with this demonstration?
Yep.
So what you're assuming is that you're looking at that propane tank and you cannot see the red portion, and you're assuming it's geometrically blocked by optically blocking it. But it's not, and I can explain why. Because when you look at the test, first off, when you look at the actual video, the guy did the test, no measurements were made. First off, so geometric obstruction was not established. All he's doing is he's lowering his camera down as close as that focal point in the middle of the camera can get above that propane tank. Now, I recreated this same demonstration, and I measured everything, and I geometrically, with measurements, obstructed an object, and then I tried to do the same thing with liquid butane. It's in that last Globebusters presentation last Sunday, and I showed this. And so when you actually geometrically obstruct an object, there is no lifting. So what actually you're doing here is you're misconstruing perspective and information loss. So like I can say it like this: you understand that the lower our eye line gets to the surface level, the apparent horizon gets shorter. You agree with that?
I don't know what that means. I have no idea.
So you're a 6 foot tall observer. You're standing on a flat surface. Okay, let's just imagine, and you can see you have an apparent horizon, and then you lower your eye level. The lower you get to the ground, that horizon is going to apparent. It's apparent, and it's gonna get closer to the observer. So you're gonna have information loss at a distance due to angular resolution. So let's say, again, we're imagining we're on a flat plane, and you're 2 inches above the flat plane. Miles away, you won't be able to see something that's miles away, even if you have a direct line of sight to it. You will start to lose information due to angular resolution. And so you're assuming in this propane demonstration that it's geometrically blocked, but it's not. It's optically blocked.
Well, if you want to finish, I want to interject next to Zanuck, and then you can go. But go ahead, Bambi.
No, go ahead.
No, that's a very interesting point. That's a well said, and that's awesome that you replicated it. And I would like to. You said it was on the Globebusters. Do you have like a video like separate from that, or is that where I should look to find it? Because I want to see a little bit. I saw what Alan had showed here, but I want to see.
At the end of the Globebusters presentation, I go over it. I have the own video, but I don't have a YouTube channel that I upload stuff to. I could post it.
Is that on the Globebusters site or something for that video?
The Globebusters YouTube channel. Just yesterday, I did this presentation, and yes.
Here's the problem with
well, Zanuck, hold on, I wasn't finished. I wanted to say my thing. So, dude, yeah, no, that's awesome. That's very interesting you said that. I just wanted to say that because when I was saying to Zanuck like that he could test it, I was just kind of going off, the idea that the red thing is actually lifting up over it, and I've never really gotten to the bottom of it myself, meaning of really what was going on there in that video. Because yeah, like you said, he didn't measure everything. He didn't really show exactly what's going on. It's a little unclear, so that's why it's hard to reach full conclusions. Obviously, these guys claim they use the argument for it's lifting up, therefore you can see over the curve, obviously, but this is a little bit different, trying to get the occlusion and whether a refractive object can do the occlusion. But I'm just saying Zanuck's thing of lopping off the green layer, having just the red, putting a laser behind it, trying to get it to lift up and block it. That all goes off the principles that it is actually lifting up and doing that.
Exactly. That's the whole point. Yeah, exactly.
Right.
Exactly. Yeah. So really, what I think is happening there is you have geometric line of sight to it is confusing when you don't understand this, because there is information loss due to perspective. This is a real thing. Anyone can test this. And so what do you mean no?
there is information lost. It's called the Rayleigh criterion is the best way to look at the mathematical representation of what you can and can't see with your eyes based on the size of your lens, based on the wavelength of light and the distances. So yes, there's no question about it. We have a 0.02 angular resolution limit. We're not even close to that with this object. In fact, if you have a laser light, we could probably see that 5-10 miles away. Maybe 2 miles away. A little, some kind of generic light laser.
You'd be surprised how fast
you can see it, and you can put it next. You can put it. Hold on. You can put it next to some flat plate. If you could conceive of a flat plate going out for a mile. In fact, by the way, I've done this before. I've seen a laser that travels a distance next to a surface out at Slack back when we were able to get in there more readily, and that's 2 miles long, and you can see the laser. So
okay, here's the difference. Is that
you agree? You agree you can see things that are 2 miles away? Headlights.
It all depends on the elevation of the observer, and so in the lower you are to the surface, the more information we start to lose at our horizon, and it happens very quickly.
No, so the Rayleigh criterion talks about
a quick example. Hold on, Zanuck. A quick example of that. I was thinking, like, I know this is maybe not the best kind of analogy, but if you're like a basketball court, I know people are saying, "Oh, the basketball court's not level," but the idea though, like if you have something like that, a basketball court, you could put your eye like 1 inch above the court, but you're not gonna be able to make out all of the lines and the free throw lines and the three-pointer lines all the way across the court. Even though if your eye's an inch above it and the court is level, technically you have line of sight, like you should be able to see every line, but you can't because it's compression. The angle is very, very acute when it gets right down to that point. So that is a factor. And Zanuck, Leslie, you don't know for sure if that red thing is actually geometrically behind the tank or not. You would have
the measurements. I've recreated it and I've done the measurements, and so I'm not saying that like my experiment is definitive, but what I'm saying is once you apply a little bit of measurements to this, the effect goes away. Once you geometrically obstruct these objects, you cannot recreate this. So you can only and you then do it, because I would love to see that.
You said I could talk in geo. Let me to my place now, because so first of all, the Rayleigh criterion talks about being able to differentiate two objects. It still has the 0.02 degrees limitation, but it's not a matter of whether you can see it or not. You can see it as long as it's within 0.02. What it talks about is whether you can differentiate between two items. People always confuse that with like the horizon or the layer of the lake or the ocean, and then some object in the distance. Yeah, there's this laterally, it's huge. It's all the way around you, 180 degrees. It's very big. But vertically, it's very small. The sail of a boat, for example, you can see, and it doesn't go away. It doesn't evaporate into the surface. You might not be able to tell it from the surface if it exceeds your ability to resolve 0.02 degrees. This thing, and jumping to your claim that this thing is not geometrically aligned, yeah, you could easily set up a laser, an accurate laser, and have it shoot up that barrel and have it just touch the top of the red thing and then drop the red thing 1 millimeter. And you can look at your camera and it will be you cannot see it. You put it up 1 millimeter and it hits the laser, you go down with the camera, you will be able to see it. I guarantee
that's not what he did, by the way. That's not what he did. He did not geometrically obstruct it.
Hold on. So you can do these kind of tests. If you want to test lasers along a surface, they go for 2 miles, go to Slack, you can shoot a laser down this thing, you can see it for well over, a mile, not a problem. A laser being shot to you near the surface. So what I'm saying is that we can replicate this, and this laser's in the distance behind this clay structure. We lap off the green one, so the red one is just below the surface, and we see the laser shining right at us. I contend that if we drop propane or liquid butane down it over the cylinder, it will loom that structure up, and it will block the light behind it. That's my contention.
Yeah, it's backed with no demonstration. So you need to do that demonstration, because that's never been done.
Yeah, never been done. That's why I like talking about this. It's cool, right? Yeah, you're challenging me. I've got my hypothesis, and you have yours. You've had your experience too. You've already done some of it. I'm saying that you're wrong, and I'm going to try to show you why.
I would love it if you tried.
I have a question to that Rayleigh criterion guy. If you were to make this demonstration to prove that you indeed can lift things up with refraction when they physically obstructed, you would have to have some standard, some kind of equation that you can use to test if the object you're looking at is physically obstructed or only optically obstructed according to your theory. Because if you don't have any standard, then when we make this demonstration, you could always just say that it was optical, like it wasn't a physical case, it's another optical case. So what is your standard for determining when is it optical and when is it physical? Is this some sort of equation or whatever that we can use for doing that?
And are you talking to me or somebody else?
No, I'm talking to that guy to that other guy. Yeah.
Oh, you would geometrically measure everything, and so you would measure the center of the camera, the focal node right in the center, and then you would measure the obstruction, and you would put them at the same height, and then you would put your target object lower than the obstruction. It would all be measured geometrically, and I did that. I did that in the video, in the Glass Globebusters video.
Okay, so it has to be like physically in relation to like the direction of gravity. It has to be higher. The obstruction has to be higher, and the object has to be lower. I'm still kind of confused.
That's what a physical obstruction is.
I mean, that's what I'm trying to understand. I'm kind of confused why the specific direction of down is the thing that determines if it's physical or not. Because when you think about this, down is just a direction that we establish because this is the direction perpendicular to where things fall. Like, it doesn't have any physical significance behind, except this, that this is just a direction determined by acceleration, like where things fall. But so why would this have some sort of impact on obstruction of things? Like, I don't see any correlation here. Look at what I mean. But why can't I establish like an arbitrary random baseline that wouldn't be horizontal, but would, let's say, 45 degrees from horizontal and call that down? And why wouldn't I be able to measure stuff relative to that?
I actually don't know what you're asking. Why I thought we were talking about obstructions. Where did gravity and down come into this?
Yeah, because you're trying to claim that down is the thing that determines like the height relative to the horizontal, which is perpendicular to vertical, and vertical is the up and down axis. You're claiming that this is what determines if an obstruction is physical or not. So this is what I'm trying to figure out. Why is this specific direction, why is this baseline, this horizontal baseline, the thing that determines if it's physical or not? Why is it not some random baseline that you can arbitrarily choose instead?
Hold on, but we're just talking about obstruction. We're not talking about gravity or up and down. Can you see in the chat real quick if I post something? This is a screenshot from the Globebusters video from Van Bees. You see this? You see this, Embo?
Yeah.
Okay,
so,
we're just talking about if you have a viewer, a tank or a ball or whatever, an obstruction that and then you have objects. The straight line from that camera is technically above that red. So we're just talking about obstruction, and well, on the one side can a refracted image block something physical, occlude something, which is in terms of the celestial theodolite and what Alan was going through. But then also there's the kind of side thing that was discussed today, which is also the idea that something can be lifted up around a curve, basically, or around something physical. So I mean, are you talking about the same thing? Because this is what we're talking about.
Yeah. All the time I'm trying to reference to this because like maybe you're not getting this because you're finding it so trivial that it doesn't even have to be discussed. I think that's the problem. But when you're doing all of this conjecture and saying that it's physical obstruction because it's lower or because it's higher, the reference you use for measuring the lower and higher is the horizontal plane.
No, it's just a straight line is what we're using.
Yeah, I don't know why he's saying. Embo, let me say one real quick. Does it matter? And this is to the other. Who was I speaking to about this whole test? That was Van Bees?
That's me.
Yeah,
that one he just posted shows a horizontal. Yeah, it could be a horizontal Embo.
So either way is fine. Okay. So all you're saying is that we want that object below that line, so it can be obstructed. That's what you mean by being lower. I think
you have to establish geometric obstruction. That's what
we can do that. We can do the laser. We can visualize it. If you don't like visual, we can put a big long. Well, I mean, it wouldn't be good to have a straight.
However you want to do it, it's fine with me. That's fine with me.
Laser.
Here's my big point though.
Well, I don't know why there's a problem with us understanding that when this red thing is not seen, why you think it actually is seen, but due to things, the Rayleigh criterion or something related to it, why suddenly we can't see it, even though it's in line. But you're saying it's not in line, and it only can't be seen because it's too close to the surface, in line with our vision, which doesn't make a lot of sense to us. I speak for Embo as well.
Well, it is a little confusing because when you optically obstruct something, it's not geometrically obstructed. It can be a little confusing, right? Because it looks obstructed, but that's what perspective does. And so yes, you.
Well, you know what? I'm going to prove that. So if I do the setup and I actually shine a laser from the camera centered on one of those like a tripod, and the laser skims the friggin' ball, and then we have a little bit of diffraction as well. But let's not talk.
Why can't you just measure this stuff? I mean, laser would probably
hit just above.
Zanuck, before you go, well, hold on. Did you forget your thing? Or I don't want to interrupt you, but dude, the thing is like. What he was talking about is how, like I said with the basketball court, you can be an inch off the basketball court and there's no physical obstruction, but you still won't see all of the lines. So would you disagree with that? He's just saying that sometimes like the obscuration of the optics is not due to a physical obstruction, but is due to the compression and perspective. Can we at least just get like, do you agree with that?
No, the lines on the basketball court do not have any height in your field of view. They don't have an angular size at all. They're just things.
But you have a geometric.
Hold on. As I go lower, I don't see the lines, but I will see the pole, and I will see things. If it's a perfectly smooth basketball court and it's not like has a crown on it, I will see things at the very base of the pole on the ground. If it's perfectly flat, which it probably won't be, but that's the point. Your experiment here. If I can shine a laser skimming the ball into the red, then I know that they're right in line. And if I just move it down an eighth of it or a millimeter, then it will be obscured, the top of it, and that should be enough to say it's geometrically hidden. Would you agree that laser test, if I can't see it and the laser can't hit it, and I have maybe a white piece of paper behind it to kind of show where the laser's hitting, and it's just above the red area, that they would be geometrically hidden by the sphere, by the cylinder?
I mean, yeah, I think a laser level would work as well. Yeah.
Okay. Yeah. I don't believe that what you're saying is true about the butane dropped on the propane tank and the red and green clay. I think that it's being obscured because it is being geometrically obscured, without any question.
That's fine, but when I tried to recreate this, I actually geometrically, I measured everything, and then I was not able to recreate the phenomenon. And I was able to recreate it optically. And once you understand that there's information loss that starts happening instantly, I mean, the closer you get, when you start lowering down, and by the way, when we have our camera focal length going right over the top of that obstruction, that is equivalent to being a millimeter off of the surface. So what you're effectively doing is like you're giving yourself an ant's perspective, and so the horizon is going to be feet away. It's literally going to be just, you're going to start losing information so quickly. And
Why?
so yes, I because that's how perspective
below
works.
your field of view. How does that have anything to do with the things that are in the distance? What happens with
the resolution?
No, that's not how it works. Regular resolution doesn't affect things that are glazy. Like if I look past my wall and things past the wall, I suddenly, because it's the walls there, I'm going to lose resolution of things in the distance because it's angularly in my field of view near the wall. No, that's not how it works.
No, but when it's all right at the horizon level, and so it's the further it goes away, the angle we have to those rays starts to get compressed, and we start to just lose that information the further it goes out.
So then, can I ask you? We were actually talking about this last night. We had like a whole thorough discussion on this. There's actually another one. Have you seen the one by the guy named Bearded Devil? This was a video that came out many years ago. B-Ball posted it. I can go grab it. It's like Bearded Devil 1884 or some number after.
I'll look it up.
Yeah, no, I can post it if you can't find it as well. But he has like 4 or 5 of them on his channel. I can post like the little GIF that B-Ball posted last night when we were talking about it. He uses like a 2x4 that's bent, that's curved. And then it's not measured though. We don't have like a third camera. It's tough. Like we don't even really know what he sprayed on it as well. It's like very limited info. It's interesting. These are the 2 tests claimed that are used for the entire globe Earth theory that essentially you can see around the curve. When we see too far and we see the extended horizon, all that stuff, these are the 2 only things, other than just basically belief that it happens, that, refraction can make you see, can lift up the whole globe Earth and make you see around the curve basically and make it all extend out. These are the 2 tests. The one that you're talking about with the propane tank, that one is interesting because you're talking about, well, maybe it's actually not even geometrically below it. So if that's the case, that one's just busted right there out the door. That's not showing seeing over the curve. And then the other one, the one that you did shows that it doesn't do that. And then the one the Bearded Devil guy does, I'll post it. I mean, it does show. He has like little blocks.
I'm looking at it right now. Yeah.
Hold on, man. Let me get in when Gio's done. Go ahead, Gio.
Well, I'm just saying he has little blocks and a little laser, and then he sprays some kind of we don't know what it is. I don't think it says in the video. It looks like a spray can in one of them, so it's some kind of cold gas something. And then it goes boom. It does do this big wavering kind of thing. And then they claim that's it. You're seeing around the curve that there it is. But anyways, that's just interesting because this came up and what really is going on here. And I'm just saying these are the 2 tests, and if those are both busted and they're not showing that, then they literally have no demonstration other than just pure belief that you can see.
Well, and also.
Hold on, man. Hold on.
Jeremy,
I definitely said I wanted to get in real quick.
Go ahead.
Oh, great. Thanks. I mean, that's not funny, bro. You didn't hear me say, hey, I want to get in, and then you tried to jump in on me. I mean, come on, man.
I didn't interrupt you, dude. Chill.
No, what's his name?
The snickerer. Anyways,
no, I wasn't
not you, dude.
No, it wasn't you, Bambi. It was Alsadius, a different guy. He Jeremy just figured he should have known he was next because Jeremy and I started at the same time. We should try to have awareness like that instead of someone else coming in. Go ahead, Jeremy.
I think I had to do that shit on purpose. Anyways, being able to make this thing be seen when it's geometrically blocked is one thing, but then telling us that you're going to stop that light, just the light, not the object, just the light is going to stop a laser beam, that's a whole nother ball of wax.
Right.
Yeah, totally.
Earlier, Zanuck was acting like, no, the object's going to stop the light. He acted like I was the one that was confused when he doesn't realize he's the one who's confused because he needs the light to stop the light. Not the object. The object's going to be geometrically down below. The light is going to appear higher, and he needs that light to stop another like laser beam light.
Yeah, good luck.
No, nobody's ever claimed that the light is the thing that is doing the stopping. We all agree that it's the physical object.
It's the refracted image. It has to be the refracted, displaced, apparent position of it.
They literally are saying that the refracted mountain is blocking the starlight. It's literally what they've been saying. No one's saying that though.
But the refracted mountain is not something that physically exists. The refracted mountain is simply the effect of light traveling from the mountain.
Yeah,
to the
we know
observer.
it's the light, dude. We know it's the light, not the actual mountain. And that's what I'm saying. Zanuck thinks that it's the actual mountain blocking the light, but he needs to have the refracted image, the light blocking the light, like you guys say the star is doing. The mountain's doing the star.
Well, Jeremy, that's a great point. My first respond?
Okay, why not?
Okay, so that's a great point. We're all thinking about it, right? And I think what happens is we might have a situation where if we only have one layer of refraction, like the glass and the knife, you might be right. We might have that laser just still showing through the camera and this phantom red thing also coexisting. But that's not what we're saying what happens with the celestial navigation situation. We have light bending from us to the mountain and light also bending from the mountain to the star. So it has to be 2 layers, like the glass has 2 sides.
Okay, so you're saying it's the actual mountain blocking the light and it's not the refracted image of the mountain blocking the light?
It's the actual mountain blocking light, but the light is bending down to the mountain.
Yeah,
So the
Jeremy,
mountains
there are kind of two things that are often discussed. One idea that the refracted mountain is blocking it, but you've seen Ruhif's picture with a big arc, like a big hook, as if the star is like hooking around the mountain, like a
right,
like a boomerang.
Gio, what about?
Hold on, man. Hold on,
I was
Zanik.
gonna
You
respond.
already,
I was
you
just
already went,
interjecting.
Zanik. Zanik, you already went, dude.
Yeah, go
Well, I
ahead.
didn't finish.
Gio interrupted you.
Oh,
Was he
I'm
done,
done.
Gio?
You're
You're
done.
done.
Yeah,
You're all
thanks,
done.
Gio.
I don't know. I popped in, but Jeremy was
No,
kind of
you're right. Go ahead.
So you're saying the mountain is in its actual position, because we're about to go around and debunk a lot of globe radiuses if you think the mountain's in it. So that's what you're saying. The mountain is in its actual position.
No, it is refracted down. The light is refracted down, and so the mountain is loomed up. Now, if that was the only thing happening, yes, I think you'd be right that the star would then shine through this refracted mountain, as shown by Alan's demonstration on that video of a knife in the glass of water. But we don't have just one layer of refraction from the observer to the mountain. We have the mountain to the star. So the star is refracted to the mountain, and also the mountain refracted to the observer. So two. So we have to have two propane bottles, two pourings of the butane, and a laser in the distance going through both. And then I think that will simulate this situation, and we'll understand exactly how refraction works. That's my contention. So thanks for that, because I was wrong initially. You corrected me on that, Jeremy.
The way you would simulate it is if you placed both the light source and also the obstructing object in the same medium, which will give them the same refraction. So let's say something like Jesse was doing with his water tank and his sugar water gradient. So something like that, basically.
I think we need to have both being refracted. If the laser, right? Like what I'm saying, you have to have two angle changes, two refracted elements, one refracting the laser light and one refracting the clay thing. If you don't have both being refracted with respect to the observer, you're going to have this superimposed dot with the refracted image, like Alan said and like what Jeremy said. And I think they're right in that respect. But that's why both those examples won't show what we want them to show to simulate the actual question.
Yeah, I do agree, but the water tank would work because the medium is refracting both of them simultaneously. It isn't leaving like on one out and refracting the other one. But if you have both in the same medium, and you place maybe like the camera also in the same medium, then both of them will be refracted by the same medium. So it will give you this effect that they won't overlap.
All right, man. Here's the thing.
Maybe that's true.
If you're saying that, hold on, man. Hold on, bro. You guys aren't turning this into a Glober fest. If you had the actual mountain blocking the actual star, and that whole image is being refracted up, your occlusion time would match. Your occlusion time doesn't match. So what you're saying is just bullshit.
It's important to understand that the optical
occlusion time would match. Can we address that, please?
Occlusion. It's just the path the light takes to make that physical occlusion happen.
Can we address that if what Zanik said was happening, the occlusion time would match, but it doesn't?
But why would it match?
Yeah, it's not going to match.
Because it's just this whole thing's happening, being lifted up a little bit, so the time would match.
It's
still happening. It's still happening. It's just a little bit higher, according to what Zanik just said. Is anyone following the combo, or is it just me?
No, the star is more refracted than the mountain is refracted to us. So both are refracted. Us to the mountain is refraction by some fraction of a degree, and then up to a half a degree or a quarter degree of this star with respect to the mountain. Two processes of refraction going on here. That's the problem. And I agree with you, Jeremy, that if you had a laser behind it, you probably wouldn't. What's blocking the light? What's making the laser bend? Nothing. You have this image that's moved. Like you said, it's a fake image or whatever, virtual image. It's raised up, but that laser hasn't been affected by anything. It's shining right to the camera lens down on the ground. So I think what you'd see is both. You have the loomed up red thing, and you have a laser behind it. Because what would cause it to hide it? Nothing. So you need the simulated situation of the celestial problem, where the star is refracted to the mountain, as well as the mountain being refracted to the observer. Both.
Hey, so Jeremy, can I try to Strawman you? So because the image, the star crossing over the path of the mountain, right, it's obviously doing that physically, and then you take that image and that's the thing that's then being projected to the observer. So you don't need to worry about refraction on the second leg. It's the mountain and the star refracting together at the same proportion. And so it's irrelevant to the measurement.
And even Jesse's example there shows that we have two layers of refraction. Refraction for us to a sign and refraction of something from the sign to the distance. Both are refracted.
I think Zanik's counter-argument addresses this well, why you wouldn't expect the time to be aligned with the CEL-THEO, because even though the refracted angle will be the same, they have to be refracted at different rates compared to their geometric angles to even get this alignment. Like the mountain has to be refracted much less than the star in order to be at the same angle. So if you want to ignore refraction, then this will give you a misalignment, because you have to ignore more refraction for the star than for the mountain.
I think you're basically throwing this in, like, there is a bit of a process here, a couple of variables moving around, and you can kind of move them around in the formula as much as you like, and I think you guys are just conflating and confusing it.
I mean, we are not even talking about formulas right now, but what is possible and what is impossible. Like, is it possible for a refracted image to change the time of the occlusion? And you don't even need specific equation for that. You only need to know how like refraction works even without knowing the specific value of how much refraction do you have.
So, are you saying what the refracted image should block the star?
No.
Okay. What's your jam?
I mean, in some way, this is the problem of semantics, right? This is what you would see. You would see the refracted image obstructing the star, but this is not what is physically happening. I think now I reach the crux of the confusion, because when you say that something is causing the occlusion, what do you mean by that? You could either mean that the observer is seeing it being occluded by this image, or you could say that this is like physically what is happening, what is photon physically being blocked by it. And if you want to say that this is what the observer sees, then yeah, I am comfortable with saying that the refracted image is causing the occlusion, but it's not what actually physically causes the occlusion, because well, refracted image doesn't physically exist. It's a matter of
at large. Is this argument about whether or not we can see through a refracted image to another piece of light behind it?
Yeah, so Geo had a really good GIF there, which is kind of very related to what we're talking about. So this has both the objects and a laser that are below the structure, physically, geometrically blocked. Everyone would
We
agree.
don't know that. That's the thing. We don't know that.
Oh, you don't
That
think
hasn't
so?
really been shown. I've never seen one that actually measured it. Van Bee's the only one that sounds like he actually measured it, although I need to look at his
let's just say-
but he actually measured it. I don't know what these two, the propane tank and this bearded devil guy. This bearded devil guy was like, he was some like anti-flat earther guy that was like involved years ago. I think he's gone. I don't think he's around as far as I know, unless he's somewhere, and it's just very poorly documented. So
Well, let's just say, for example, let's say that happens. We can also, part of our test, that this thing is below the obstruction of this table.
Well, that's the key point, though, is that
Hold on, let me just finish the thought, because this might be food for thought. Now, we see both the two blocks there, as Geo showed, the red and the black block, both rise up, and as well, there's a laser. I would contend that both the laser and those blocks are on the same level with respect to each other. But imagine putting that laser even farther behind and having another table where you're dropping green or butane or whatever, and that might show that you could block that laser because it's not part of this whole right. What's in front of you here? The red thing looms up. The laser's blocked by this two stages of this refraction. That's what I'm thinking, and that's what we're gonna have to probably show.
I remember that someone said that there are only 2 demonstrations, and I remember I had another demonstration of exactly this saved somewhere that I've been using for like maybe 2 years ago. So if you want, I can post it.
yeah, I'd be surprised if I haven't seen it, but if I haven't, yeah, I did say there seems to be 2. But I don't know off the top of my head remember of another one, but yeah, post it.
I mean, it's a very niche one. I remember I had to save the link to not lose it.
The key point in all these examples, there are a bunch of ones you can find other ones of different types of the same thing, but in all of them that I found is that no one's measuring anything. No one's geometrically obstructing the object. It's all done optically, and that's where you can misconstrue effects of perspective. At this really minute level, there is exaggerated effects of perspective, and that's what you're playing with actually here. And so, without geometrically obstructing it, it's really inconclusive.
So let me ask you this. I was going to ask you this before. So what do you think is happening then, or at least like a working theory, like without knowing exactly what their exact setup was and all their measurements?
The refraction, when they introduce another medium, what's happening is it's just redirecting the already geometrical permissible rays. So that's all that's happening. We have line of sight, but you add a refraction and it's just bending that light, playing it with your eyes. You can see a little further, see a little clearer, but that's all. And there's turbulence. Like that's what's happening. It's just playing.
Though you're seeing the same objects, they don't change their distance. The laser, the blocks are still the same distance away from you. But you see more of them.
The angle of the light coming off the table that's where the medium is being poured onto, and so all those light rays that were compressing and the information was getting lost due to the angles of light coming off of the table. All of that is getting redirected by the refraction. So it's appearing to open up your view a little bit. It magnifies, it shifts the image, it blurs it. There's turbulence. So it's just playing with the already the rays that are already there, that are already geometrically permissible. That's what the refraction is doing.
No, it makes total sense, dude. And that's what I've always told them, like in terms of the whole boats over the curve and all that stuff, is that, and B-Ball always asks this, Earth is Life, he always asks, like, what would you guys expect if it was a globe? And what I always suggest is that, like, if it was a globe, the boat would cut off at the actual geometric horizon, as it were, of what the globe would be, consistently all the time, every day. However, let's say the bow was half cut off by the curve. Yeah, that might waver up and down. You might get, it might be slightly in different position. There could be something like that, but it's not going to allow you to see beyond the physical curve. So it's like, if you had, I was saying the example, if you had like a friend that went up to the top of a mountain and half of his body was below the peak and half of his was above the peak, and you're looking up there, his whole thing of his half body below the peak, that might waver, might do things, but because it's an actual physical blockage, you're not going to be able to see his legs. There's nothing that will allow you to see his legs, So yeah, what you just said right there is would actually line up with exactly that. This is actually what's occurring, and that you're not seeing around a curve, and that you can't see around curves. Again, though, if they could demonstrate it. But yeah, so you're saying that like the optical information is not there based on the regular ambient conditions, and then adding the fluid just allows what the line of sight that is actually there geometrically, but it's just not visually acquirable, as it were, when it's in the standard state, and then the gas just allows that to be visible, which is really just what's already there, rather than actually allowing something that's physically blocked to actually become visible, which is a very opposite explanation, really, of what's going on there.
It redirects the already geometrical permissible rays. They're already there. It's just the refraction is just redirecting them. It's nothing's bending around anything. That's what I think, and that's what the demonstrations show. So I mean, if you want to prove otherwise, I would love to know. I want someone to geometrically obstruct this stuff and bend the light around, and then we can start talking about.
I mean, according to basic geometry, this even if those tribes were higher, then they would still be geometrically obstructed. So to say that they weren't geometrically obstructed, you have to basically invent your own geometry. And I would say, if you want to do this, then it's not really a burden of proof on us to prove that it exists and that Euclidean geometry is fake, instead of the other way around, that we have to disprove your magical version of geometry. I don't think this is how it works.
Wait, where are you getting that from? If you were to measure it, you're just using a straight piece of material to measure to see. We all know, like, if you're walking around a doorway and you're blocked behind it, you're not going to see the person behind it, and you could take a measuring stick or some straight object. So why would you have to change anything about geometry? We're just talking about very basic straight paths or not a straight path. If three things are lined up, it's just like the idea of an eclipse. They're either three things are lined up or they're not. So, well, in the globe model eclipse idea, anyways. So what's the problem with that? You don't have to invent geometry or anything. You just need to have it straight. You do have to have some way to confirm, something very straight. But the good thing about these shorter distance things is that, you're not having to deal with something that's 2 miles straight. You just, 8 feet or 10 feet or whatever.
But that was my point. If you were to take a measuring tape and create a straight line between this object and between the camera, then you would reach this propane tank. Like, the propane tank would be in the way of the straight line. It would be geometrically obstructed. So in order to say that it isn't geometrically obstructed, you have to reinvent how geometry works, basically. Because according to geometry, if you draw a straight line between the target and the camera, then it would be obstructed by the propane tank geometrically.
And how do you know that? Are you saying that just based on how it looks optically?
Yeah.
Yeah. See, that's kind of the contention. You're ignoring perspective. That's what I'm claiming, and that's what I showed in the demonstration. I showed in the Globebusters. Is that when you
Oh, go ahead.
No, I'm just repeating myself. When you do geometrically obstruct the object you're trying to look at, it does not lift up. And so what you're saying is that if I pulled a measuring tape and it would hit that propane tank and it would obstruct it. Well, I'm saying no. You're misconstruing perspective. If you did do that, you would actually find what I'm saying is that the red would be geometrically visible. The tape would go all the way to the red. It just optically looks like it. That's what's confusing. That's why this is, and even the demonstration is because it optically looks like it, but that's perspective. And at these minute levels, when you bring the camera a millimeter off the freaking surface, you're playing with this perspective, that starts to happen very quickly, right in front of your eyes.
Right. And it's like Rayleigh criterion, like down at that angle that's very, very acute. Like between basically we're talking about, let's say there was a straight line from the camera to the red clay, and then the tank, it's just above the tank. Then the angle from the camera to the top of the little layer of red clay to the bottom of the red clay, however big that is, a quarter of an inch or whatever, and then that angle coming back to coming back where the tank is to make a very, very acute triangle, like an incredibly acute triangle, of the straight line, the angle from the camera, and then the red clay is so tiny that when you have Rayleigh criterion and the distances involved and so on, I could see what you're saying, that possibly that is just being visually obscured, due to the optics, which is something that happens, depending on, like you're saying, the setup of it and how far you can see and the angles as it gets down, you can lose some information. Same idea, like in a way, like I know I was saying before, it's basketball court, but you can also say like a chessboard that has white and black squares or something. And then, if you put your eye really down to it, you're only going to see like 2 squares, but as you raise your eye up, you're going to see more and more and more. So the fact that when you're down at that really low angle, you're only seeing like all the other squares are just gone. They're lost. If there's 30 squares, you're only seeing 2 of them. To where did the rest of them go? Because the angle is so acute. The ones that are closer to you, you'll be able to see because the angle is wide enough and the angular resolution and all that. But beyond a certain limit, that's it. It just blends in with the the horizon essentially.
But even if that was true, even if there was some small, very small part of this red clay that was visible geometrically, even before he introduced that medium, that still wouldn't change the fact that he still demonstrated that the rest of these red parts came out from below the obstruction, because we can see that after the refraction, this red part is much, much bigger. So even if there was some very small, not discernible fragments before this refraction, then after this refraction, much bigger portion of this clay was visible enough big that you can definitely resolve it. So it will still demonstrate that you can leave things from behind the obstruction.
Well, refraction can magnify. So, I mean, there's a lot of things that refraction can do. And so because, I mean, it sounds like you're saying the amount of the red is proving that, you know, that's all dependent on the amount of refraction, how much it's magnifying those light rays, you know, the effects of what's actually happening. And I don't think that, I mean, the way to differentiate this is to do the test and to geometrically obstruct it and show that it's lifting. And I plan to do more of these tests and you know, to get to the bottom of it, because I've done like a couple of them. It's not definitive. You got to do a bunch to really kind of figure it out. But yeah, I mean, yeah.
Well, it's a really good point you bring up, because a lot of people who see that, they just figure, oh, well, since it's visually not there, you can't see the red, it must just be obstructed by the tank. That's what most people think, you know, right off the bat. And I'm not saying I know 100% because I haven't seen that set up. Obviously, he didn't take measurements. I have not tried this specific thing myself, you know, so obviously I'm somewhat limited. But it does make sense what you're saying from everything I know about just optics and the horizon and Rayleigh criterion and the some people call it the angle of incidence or the angle of attack in terms of how the horizon forms, because there is essentially kind of like an artificial horizon being established there with the tank and then the objects beyond it basically, and then the camera. So yeah, what you bring up is a very good point. And if that's true, if what you're saying is the case, then essentially you've just debunked that, which is awesome, because I mean, it's been posted for years, and usually when we're deep in refraction and how we see way beyond the geometric horizon and how the Earth has, you know, is empirically observed to be planar and doesn't have the curvature, and then they say, well, no, there's this effect happening, and then that's usually the go-to that they'll go to. It's either that one or that one, that the bearded devil one that the B-ball posted. So yeah, it's either one or the two that are generally posted, and that propane tank one is kind of been like one of the old things they have that they think shows it, and they're like, boom, there it is. But if you've debunked it, that's a good work.
Well, the telling thing about all of them is there's no rigor, there's no scientific rigor done, there's no measurements. So I mean, like on the face of these demonstrations, if you're going to put all of your belief that terrestrial refraction can be bending light around an obstruction into these demonstrations, when all it takes is just a little bit of measuring to show something completely the opposite, you know, there's no rigor in these demonstrations. So
for sure, yeah.
So yeah, and then once you add a little bit of rigor, a little bit of measurements, you start to get much different results, and you start to apply the concepts of perspective and understand that, and it does start to make a lot of sense about what's happening. But yeah.
I actually have to agree with this, that I also don't really like the lack of measurements and the lack of math in many of those experiments. I like very rigorous testing. But can I ask what kind of medium did you use for your refraction in the experiment?
Yeah, I did the same thing they did. I used liquid in the propane tank example. He used liquid butane, so that's what I used. It was $5 for a can, really cheap, really easy.
Nice.
That is easy. Yeah, because they have butane like for refillers for lighters and all kinds of stuff.
Because I think I could do this, but the way I would do this is with a water tank with a density gradient inside, like the way Jesse did. But I'm not sure if the authors would accept that, because I've heard that some don't accept it because they consider these two different media. And that's why it doesn't demonstrate refraction for them, because it's two different media.
That's great. So you're saying
go ahead.
You're saying you tried to do this thing and you couldn't do it, make the thing rise up so it was visible?
Who are you asking?
Yeah, he just did a demonstration on it.
Not you, Joe.
Are you talking to me?
I mean, that doesn't mean you. That doesn't mean you can't.
And he measured it. He did it and measured it, and that's what he got. Yes, I mean,
I'm saying that doesn't mean it can't be done though, right? Like maybe he just didn't do it right or something.
No, obviously, yeah. When I said before, like, you know, like if I wasn't saying he has, in my view, I'm not sure it has been debunked, at least in my subjective viewpoint. So I don't know if even Van Bee's claiming that it completely is, but it.
No, I already said it's not definitive. I did it. I did a couple of them, right? And that's not like you got to repeat this. Science is verifiable, repeatable. So like, yeah, I'm not claiming to have debunked it, but this is what I think is actually going on, and I'm going to do more tests. You know, but I found that no one within these types of demonstrations, no one is geometrically obstructing anything. There's no measurements being done. I haven't seen any in all of them. And when you do geometrically obstruct the object, you can't. I'm finding that there is no lifting happening. So
I've been kind of waiting for a break in the conversation. So even if it did work the way that the Globers are saying, what it proves is when you add the independent variable of liquid butane, it causes light to refract, not standard atmosphere. So it's a reach to begin with a weak inference. Oh, if it happens with liquid butane being introduced to the atmosphere, then it must, happen when atmosphere is introduced to the atmosphere. So it just doesn't make sense from the get. It just shows the despotism.
Yeah, I agree. There's more problems with just not geometrically establishing obstruction. Yeah, I think you're completely right. They're not. I mean, the conditions aren't being mimicked of terrestrial refraction. It's different.
This also technically wouldn't be even exclusive. I hear the point Larry's making as well. It's a good point that it's not actually direct replication. It's a different scenario. And just in the same way, like using a laser through sugar water, it's like, well, that's not the same as looking through, the atmosphere and grand distances. It's not the same thing. Although, I mean, there could still be some overlap, and that's what is interesting. But another thing about it too is that let's just say you could see around corners with certain conditions. Let's just say you could, for the moment, hypothetically, if you could see around a physical obstruction because of some light effect or some etc., that still doesn't mean the Earth's a globe. Even at that. So it's really not even exclusive to a globe. Like it would be required, or something like that would have to be required, because obviously we see way beyond the geometric horizon. That's just no doubt about it. Therefore, it would be needed for. Seems like it would have to be somewhere in the mix for the globe theory to be even viable. However, it's also not exclusive to a globe. Like technically you could see around things, if that's the case hypothetically. You could see around physical obstructions, and the Earth can still be planar and stationary, and you just see around things on a planar stationary Earth. So I'm just saying it's also not exclusive technically, even if it was shown.
It disproves the globe, but not flat Earth, basically.
Right, because that could still happen on a flat Earth. Yeah.
Yeah, but the globe needs refraction to be bending light around the ball. It needs it.
Well, flat Earth needs it to be needs light to be bending in some cases also.
Like when you measure concave Earth, like one of those cases.
Yep.
Yeah, when we have the oil rigs that are much higher than level in distance, completely in contrast to the laws of perspective, where something that is at eye height should be at eye height indefinitely in the distance. Now it's above eye height. How does that happen? There has to be a reason, right? It's got to be refraction, unless you have another idea.
Well, it turns out refraction is caused by these little particles called refractinos.
Dark polarity.
Dark refracto-decepticons. Refracto-decepticons. I just made that up.
So you don't think that doing it with a different medium, like with butane or with water and sugar, would be valid? Do you think it has to be replicated with the atmosphere?
Not if you're outside the water tank. I don't think so. It has to be all, because we're replicating terrestrial refraction. That's all within one medium. When you add a second medium, you add other refractive effects that happen at the boundary of those two mediums.
That's actually a good point. Yeah.
Embo, you got a girl? You got a girlfriend? A wife?
No. Why you're
I was asking for a friend. I was asking for a friend.
I have a question for Jesse in regards to what you just said. Refractinos, I think you said. Is that right?
Yes.
Yeah, but they're very, very shy.
I've never.
They're very shy. You really have a chance to see them.
It was just a joke. It was humor.
You learned that in MSU.
What is MSU?
It's like
not Michigan
neutrinos.
State, making shit up university.
Oh, okay.
Oh, come on. That's where I went to college. I went to Michigan State University, MSU.
No, it's tough. It's tough.
That's tough that you made up. What is it? Make shit up? Okay. Well, the same letters.
Well, I thought you went to that other school in California there.
Yeah, I went to undergrad at Michigan State University, and then my grad school was in San Francisco.
I see. Where did you grow up?
In Michigan.
Oh, okay, that makes sense.
Bro, what you writing his biography? You doing a documentary?
I like to document every part of his life.
We're asking the questions here.
Dude, we talked about Ruhif's. We talked about Ruhif's personal life for like 4 hours last night, dude. We were talking with Ruhif.
Oh, really?
God. I mean, he was fine to say it all, but oh my God, he told us about his family, his childhood, how his father. I mean, his father. Oh my gosh, I don't even. It was intense, dude. So many things.
What, his father beat him with a belt or something, or what?
How he made all of his money. What?
Like what? Like you mean like was there anything worth mentioning? Like anything interesting worth mentioning? Like did his father beat him with a rod or something? Like.
Well, actually, the topic came up because we were talking about like discipline and corporeal punishment and all that. And then we said to Ruhif, like, Ruhif, do you hit your kids? And he's like, no. And I was like, you know what? I would have pegged that on you. That's awesome, dude. Like, you don't hit your kids. He's like, nope, not at all. And then he said the reason we don't is because he said his childhood was really rough, and then his wife's was as well. So they just decided, let's not hit our kids, kind of thing. I mean, it's all public what Ruhif shared. He obviously knows this is live streamed and everything like that. So I mean, but I mean, dude, if you want to highlight real, I mean, he just said how he made his money in the finances. He made his millions, and then his dad, like he was like, he retired his parents. Like he was willing to give his parents like about $3 million, in a monthly stipend. So he was basically kind of retiring them, agreed to. And then I guess his dad, dude, I don't even, his dad, like basically, his dad didn't, like, Ruhif was very estranged from his dad, and so his dad didn't even know where he lived. But apparently his dad like stalked him, found out his address, him and his wife drove 4 hours down to where Ruhif is, snuck, basically parked their car down his street, watched him come out of the house, followed him to the pub where he was going to have a steak and a scotch. He said he likes to go have that. And his dad came in and confronted him. You know how parents like grab the kid's ear? You know, that old thing, the kid grabbed the ear and, well, that's what his dad did. And then Ruhif like pinned him down to the ground. They got in like a scuffle. And then his dad like did a death threat. So his dad like threatened, like, there's going to be 2 people that are going to come to your house and kill you tomorrow. And then I guess there was like he was arrested and charged, and there was a whole restraining order. And then he didn't, he could have just accepted the restraining order, the father, and then Ruhif would have kept giving him the money, the retirement money. But instead, his dad decided to take him to court. So Ruhif had to go for like 3 or 4 hours in a court to defend himself that it was a real death threat, and that it was, he was trying to say it wasn't. And all he would have had to do was just accept the restraining order. But instead, he decided to, contest it in court. Apparently, his father lost in court, and then Ruhif ended up, pulling the money, basically pulling away the retirement money, and that was a whole hard decision. And then there's this whole other thing where his the software that he made for the financial stuff, like there was claims that he had copied it or like stolen it from someone else. Apparently Ruhif says that was not the case, but there was a whole court case that came up around it. And apparently Ruhif said he won that case, but his dad, like, even though he wasn't even involved, his dad apparently like called the opposition and made up a bunch of lies and tried to like screw Ruhif over. I don't know, man. It was a whole bunch of intense stuff that he was sharing, but I guess that's kind of
Oh, so why would his dad try to kill the goose that lays the golden eggs?
I know, dude. That's why it was such an intense story. Like I know, like, but talk about bite the hand that feeds you. Like,
I mean, did he even need Ruhif's money though? Or, I mean,
yeah. Sounds like it. Yeah, like
you can always use more, dude. No, I'm good. Dude, you can always use a little more.
Sometimes it ain't about the money, though. You know what I'm saying, Jake?
Yeah, I get it. I mean, yeah, obviously, if he's like, if he's like George Clooney rich, he doesn't need the money. But like, if you're like,
nah, even if you're broke, it ain't always about the money.
What's the other part of the story is that he said Ruhif's dad, like, he didn't really know how much money he actually had until there was that article that was like the youngest millionaires in Australia or something, and Ruhif was on that list of like top 30 or whatever it was. And when his father found that, he then got pissed off because Ruhif pulled the money, and he then was going to try to sue Ruhif for a breach of contract. But apparently Ruhif said he dropped that and didn't continue that. And I guess Ruhif said he's just basically completely estranged at this point from his father and his mother. Like he said he only sends an email to his mom like happy birthday, and that's it. So it was also kind of sad in that way, like they're kind of estranged.
Did he mention to you that his dad is a flat earther, and that's part of the reason why they have their estrangement?
You gotta stop trolling, Jake.
No,
that's over the top, bro.
That would make the story just so much more juicy.
It would, but you can't just throw that in there. Like,
I know.
What's really
you guys know
is that right now I'm going through that same kind of a debacle with my family, and my grandparents have passed away, and there's 2 very large estates worth a lot of money, and that's where all of the siblings of my grandparents, aunts, uncles, my mom, my dad, and all of a sudden there's a whole bunch of just in family fighting happening.
Oh yeah, money really makes a family fucking fall apart.
Oh, we got screwed on. My aunt had mad GE stocks. Yo, if you want anything to go to somebody before you die, give it to them before you die, because you do not know.
You gotta you put in a trust before that. You got everything ready to go. You put it on a trust and automatically.
You can't like rely on someone to do the right thing, or you know what I'm saying? Just make sure you got the shit set up so they are going to get it, or just give it to them before you even die. That shit always happens.
Dude, that's funny. Excel's just posted, this says Redfoot Leveling Off-Road Leveling Ramp. This is a leveling ramp, a product. And on the side of it, it says ... because the earth is not flat. This company, this Redfoot Leveling company, actually put that on the side of their box or their product.
That's odd.
That is hilarious. Are you in here, Excel? No, he's not in here.
So what, they sell levels and their levels curved?
I don't know. It's off-road leveling ramp. It just says ... because the earth is not flat on the side of it. And the not flat is like italicized.
I think it's something you drive up on one side of your camper van to like level it.
Yeah, that's what it looks like. I thought it was either that or maybe something you pull your car up onto when you leveling ramp. Well, what is when you pull your car up so you can change the oil. Like a little
So they want to make sure your RV is like ever so slightly curving.
Well, I think they're kind of saying like, I mean, the joke might be you need the leveling ramp because the earth's not flat, so your car's not going to be flat or something.
Yeah, I know, but then they're saying levels got to be curved. So what are they doing here?
It's a fallacy. I think we should email the company and tell them right away. The inflation's
Consequent. Tell them to call Bev. Who is the new guy? Is he still in here? Is that dude from Glowbusters or?
That was Vanby. I think he hangs out with the Ether Cosmology guys. Sounds like he was on Glowbusters as well, since I think they're mostly kind of helping host that show now. But yeah, he's been on here at times, although he seems to pop in when for the Ether Cosmology events. But he's been in here other times too. He's done a bunch of good work on refraction. Like he's solid on discussing that. I've had some good talks with him in here where he's been like really on point. It's been like a refreshing perspective that he brings.
He's a breath of fresh ass, yeah. Breath of fresh air.
Yeah, so here's something else. A little bit of a side topic, but I love Mark Twain in regards to his sarcasm and his books. And one of the most interesting quotes he ever made was, "The fear of death follows from the fear of life. A man who lives fully is prepared to die anytime."
Yeah, we're ready to die on some Biggie shit. I feel you.
Kind of fucked up, isn't it?
Nah, as Biggie told us.
Biggie?
Biggie.
The rapper?
Yeah, the
B.O.B.
rapper.
Black guy?
I'm ready to die. Tell God I said hi and throw down some ice for the nicest. Dude, you never heard Biggie?
Jeremy's stuck in the 90s. Forgive him.
I don't think Andrew's the Biggie type from what I've gathered.
Definitely not. I don't listen to
What do you
rap.
listen to? Your favorite author is Mark Twain. Who's your favorite? What is your favorite song by Beethoven?
Dude,
I like
Beethoven's amazing. Yeah.
Mozart,
There's all these videos on YouTube now where like these people playing piano, and you've maybe seen where the notes are like digitally dropping towards the keys, and they light up with graphics, so you can see all the notes.
Yeah.
But these people are like really good where they can do all these like all the Tchaikovsky and Chopin.
Is that
and
the one
all
where they're
these-
swinging the swords?
No, it's just like notes that are coming down digitally. Like they're playing a real piano that like the keys light up, and then they must put some overlay where the notes all look graphically, so they're coming down, so you can see all the runs that are coming, like in the classical. It did just beautifully.
Have you ever
It's
seen
like a
the
player
good-
piano, but like on YouTube, where you can really
Have
see.
you ever
it.
seen the Guitar Hero one, but it's like with lightsabers?
Yeah, this is kind of
God.
like Guitar Hero, but just piano. But yeah, I've seen a little bit of that. You mean the VR headset where they have lightsabers and they're like, yeah.
Yeah,
So-
they gotta like slash the notes. Yeah.
My last Twain quote for the time being.
No.
The human
Guitar
race.
Hero-
What?
How many Mark Twain quotes you got?
Hundreds.
Well, let's do it.
All right, break us off with at least 3 more then.
All right. The human race has only one really effective weapon, and that is laughter.
One really effective what?
Nice one. I have a comment. Laughter. I have a comment on that. Apparently, that singing and laughing. There's like claims that like that actually like you like create more white blood cells. It's actually good for your immune system. Like there's actually biological
Laughter's the
benefits.
best medicine.
Yeah, and Rusted Soul had said that there was a woman who apparently got diagnosed with like severe cancer, given 3 months to live. She decided not to do the chemotherapy. Apparently, she just went home and watched comedy movies, just all day, every day. Just watched comedy movies, just laughed her ass off. Apparently, the story is she went back a month later, the cancer was completely gone. So when they say laughter is the best medicine, pretty interesting. And apparently, singing as well, just singing has certain positive effects as well. So just keep singing and laughing. Apparently, it's good for your health.
Yeah, in India, they actually have this type of laughter medicine where people just get together in a big group and they do like these really weird type of like gestures and stuff, but it's forcing you to laugh, which they say is it's used to actually cure depression.
Thing that you're talking about with the people that act like they do like this real big belly laugh and they like stand in a circle and
Yes. Well,
Yeah, I've
in,
seen it.
in large groups. Yeah.
It looks mental though, just watching him from the outside. Feels inappropriate to laugh at for no reason, but it's funny to laugh at them. It's just, I guess, the whole affect, isn't it?
well, every human knows that it's easier to lift something if you make a noise while doing it.
Well, that's interesting. Actually, that connection, I didn't think about that. Also, in tennis, when they do those grunts, I never get why they grunt so loud, but it must be part of their game, Oh, those huge grunts.
It helps. You get more power when you grunt.
So they're really doing it for. That's really a
I
thing.
suspected that there
No, I
would have
made
been
that
a
up. I
factor
have
there.
no idea.
You made it up.
That's cool.
I made it up. Rick
It
CT
sounds
promised
right.
me.
It sounds right.
It does
I'll
sound
go
right,
with
but
it.
I did.
All right, last Mark Twain quote for the time being. We have the best government that money can buy. Think about that one.
Yeah.
That is funny.
Didn't he call his friend Jim by a racial slur?
Really care.
Oh, I would just change it. I would say we have the best government. Money can lie. Just got to fix it.
What? It's a Mark. Well,
Lie instead of lie.
Samuel
Replace
Clemens.
lie with lie.
His real name. Mark Twain is the pen name for him.
Anyone else obsessed with pomegranates, or is it just me?
They're all right. They're kind of
Probably
hard
just
to eat.
you.
You
That's
juice
kind
them?
of weird. All right.
No, I just cut them in slices and tune into Earth's Awakenings.
Nice. You eat them seeds and all?
Yep.
I've had the seeds aren't bad.
I've probably ate
seeds are
50 in the past 2 months.
All right. Question for everyone.
I think it's in season, right? Or it's
Yeah.
kind of a fall fruit. So yeah, there's a whole thing about eating fruits that are in season. So that's a good time for it. I mean, they're really good at antioxidants, and that's like a kind of like more closer to like a super fruit rather than just a regular fruit. Go ahead. Andrew.
In 2026, which is right around the corner, there's going to be certain things that are happening. If someone were to say, here's what I think is going to be happening in 2026, and let's say you had like $100 at the table, boom, there you go. What do you think?
I have one. I'll put all my money on. We're not going back to the moon in 2026. I'll put it on that one.
No. What's going to happen? You know?
I know. Well, they say they're going to try to loop around the moon, so I shouldn't even say go back to it. I'm saying they're not going to go to the moon. They're not going to loop around the moon.
Yeah,
Okay,
it's
if you're
like a
saying what
double-
will happen,
double
not what
negative.
won't happen.
Yeah, that's like a triple negative, I think.
Does anyone want to start making bets on 2026?
I will. Yep, I'm a betting
What
man.
you got?
I'm
What
a
you got?
gambler. I don't think that Donald Trump is going to make it all the way through the end of 2026.
Like he's gonna die?
Oh.
I don't know if he's going to die, but I don't think he's going to make it.
What do you mean make it? Make it means dying and not dying to me.
Well, no, he
Is
can
he-
resign.
Oh, he's not gonna finish his presidency out? I'll put $5
Yeah,
on that.
I think JD Vance is going to take over.
You want to bet $5?
I'll bet way more than that.
Well, I'm not really a gambling man, so I mean it's $5 or not, pretty much.
I think it's called Bet Moose. That's like the
What's
website.
that?
What is it? Just a hunch, or do you have some reasons to think it might be like
This
other
guy's
than a hunch?
hustling. He's hustling me, Gio.
He's old. And
That's fine. Biden was old.
Yeah, but Biden also had dementia. That's different.
How does that help?
I'm just saying that's my bet. I'll
bet you
put my
$5. You want to bet $5?
All right.
No, Biden didn't know what was going on. He was like Weekend at Bernie's.
2026 prediction. Dual pole is going to be a bit of a talking topic, and the celestial theodolite will continue on dominating. Probably that dual pole is probably going to get a little bit more legs, though, for sure.
I have no doubt that the celestial theodolite will continue on, but with its 500 plus meters air, I don't think it's going to ever be dominating.
All right, it's kind of off topic, but okay.
Oh, dude, you were asking about 2026. He said celestial theodolite. That's what we were talking about.
Oh,
It
that's
would still be
good enough.
dominating. I agree. Hopefully, somebody from the southern hemisphere can do some observations. But
I should get some more observations from sea level. Collect that $50.
So you go to the sea level where Re-Adresses says it's the worst place to go, right? And if you want to prove the shape of the Earth, you go up really high. That's what Re-Adresses says. But for some reason, you want to seem to get as low as you can.
Well, Alan.
But you're not cherry picking. You're not cherry picking.
Alan is offering $50 for each new occlusion or peak for star occlusions, from any elevation in the southern hemisphere and at sea level in the northern hemisphere. So he's put a bounty on more data.
No way, really?
Yep. So you could make up to $300 if you could get like 6 occlusions or occlusions to 6 different peaks. That's US dollars too.
Well, at least he's honest enough to sort of continue on getting that data that supposedly is not the best way to do it. I can't remember his exact description to me. But anyway, yeah, 2026 dual pole. Year of the dual pole. Let's go. Gatebreaker is going to produce a big 3D model for us. It'll be pure. It'll be all over.
I think the hardest people that's going to be convinced is the flat earthers on that one.
It might be actually, yeah. We'll send him to the gulag once we work this shit out.
You know, it's funny. It's like some of the globe earthers, it seems over the years, have kind of liked the AE map. Maybe because it has certain problems and issues, and maybe because maybe even they had a gut feeling like, well, if it is flat, this ain't the one. I don't know. That's speculation, but like there was a part where they, kind of liked like, oh, the ice wall, and just kind of trolling with it, and the no 24-hour sun and all that stuff. But as far as I can see so far, the dual pole is like absolute kryptonite for the globe folks, and maybe for some flat earth folks too. But the globe folks are just like, no, like they really. Like, I haven't heard one that's kind of like, okay, maybe one or two. I mean, have kind of had some neutral view, but and then a lot of them want to just say, no, the AE is the only one that can work. To kind of shuttle everyone. To keep them in AE in a way. And then you have people on the flat earth side, as it were, that kind of also want to keep people on AE. Like either they're saying the TFE was fake, or so. Yeah, I mean, what you're saying, Rixky, if it does get some more interest, I mean, it seems like it has been in the last couple months, at least to some extent. Like Roots was saying that New Perspective was talking about it over on 24/7, and there was kind of a buzz over there and those guys, apparently. And so, yeah, it would make sense to me that it's going to continue to be discussed more.
Yeah. I think the most interesting thing about it that seems to be pointed out is this convergence and divergence in the East and the West. And I haven't quite thought this all the way through, but I mean, you guys seem to be suggesting that doesn't happen, or it shouldn't happen on the globe. And they're saying the globe is saying that it doesn't happen. And that's about as far as I've gotten through. But obviously in those photos that we see, we can see that phenomenon going on. I just can't work out if that's happening in the lens or something else. But I mean, if that is a unique observation and it's like fully legit, I mean, dual pole is almost the only one that does resolve that. I'd really like Alan, and I have heard them murmuring in the background saying, nah, there's no way the dual pole could work. But I haven't got a formal response to them as to why they don't like it. I probably should have asked today, and I was going to if it was going to be a little bit quieter and a little bit more friendly, but it seemed a little bit divisive anyway, so I didn't want to sort of like putting challenges or making Alan talk on something that's like maybe not within his sort of field of thought right now.
Yeah, I hear you. I don't know if we're going to go into this whole topic or not, but I mean, I think there's a whole bunch of challenges / issues that I have with it as well. Like, I think the two pole makes a lot of sense in terms of the sky, and obviously the straight lines at the equator. There's really no other layout it could be, especially like I've always said, when you have just one GP for every celestial body and all that. But anyways, without going into all that, but I mean, how the actual map works and all the different components and how the sun moves, and it's like an electrical circuit.
Watch how you say that, Gio. That you said you don't see how anywhere in any other way that it could be.
Well, what I meant by that is that if you have one GP for every celestial body, unless you have two GPs, I don't see any other way that it could be anything other than a two-pole planar Earth. Because, like, if you have Polaris above a certain point on the ground, then all those other stars coming out are all at points above the ground. Then you have a whole southern pole as well, and you have the southern stars. Sigma Octantis is under a place on the ground, and then all the stars coming out from Sigma Octantis are also at places, with one GP, when they're all spaced out the way they are, and then celestial navigation and all the rest of that too. Yeah, I just don't see any other way that the land could have any other layout other than two poles with the land laid out in between it. Why are you saying? You're saying be careful because there could be another way that I'm not aware of or something? Or do you?
Yeah. Not only that, just because what's his name had that same idea, Jaren, about the layout, and if it got debunked in a way that he thought it got debunked, then his whole demeanor just could handle it.
Yeah. Well, he's doing the thing. I mean, I hear his whole thing that the 24-hour sun doesn't work on the AE map. The thing that he does is says there's no other planar Earth layout that works, but there is, which is a dual pole. So I don't know why he is not aware of that, or maybe he's been shown it, and maybe some of the issues that we all have with it, maybe he just instantly said, oh, it can't be that, maybe. But I hear what you're saying. It just seems like we have two massive hemispheres, straight line at the equator, two poles with the 2-star rotations. So, I mean, yeah, at this time, I don't see any other way that there could be anything other than a dual pole, but it doesn't mean that it couldn't be another option, because I haven't mapped or modeled the whole Earth to know all the answers yet.
What I would suggest for people to look up and even buy are ring magnets. And you can test these with iron filings. Kind of weird how it works. Fairly inexpensive. It's kind of weird. There's videos online, people doing it. I've done it myself. Right now, Jaren is going through a phase of his life. I don't know if it's controlled in regards to money or whatever else, but he has definitely shifted very, very quickly. I'm not going to say anything negative about Jaren too much, at least, but he definitely shifted very, very quickly. And that's fine. People do that. And that's about the limitation to what I'm going to say at the moment.
Yeah, well, I would just say, just finishing on that last, what we were saying, like what I've always said is that, like the whole thing where if you have the GPs, you put a little flag in the ground underneath each ground position, and then you'd have 2 massive poles on the ground, just like you have 2 massive poles in the sky. The only thing is, like, if there was more than 1 GP of any one star, then there could be ways that it could be something else. You know, like in terms of if there was more than 1 GP for particular stars, then you could have maybe like reflections or other kinds of things going on.
Could show you something cool in Blender if you're interested regarding that.
Are you proficient with Blender?
Just barely to do what I need to do.
Okay, cool. I am an amateur with it, but I have it downloaded and I've been experimenting. So yeah, show us. By the way, Blender, for everyone else, is an open source type of 3D modeling type of software, open source. Are you going to share?
Yeah, I'd like to share only if Geo would be personally interested in looking at it. If not, all right,
There's
sweet.
a lot of other people here that want to see what you're talking about.
Yeah, I mean, I'm live streaming it, so feel free to tune in real quick. Yeah. So I'm just not gonna I'm not gonna share my opinion on what I think about it, but I'm just gonna show something real quick, and I'm going to explain it. There's only a few people here that's going to be able to understand, but so you have your dual pole here. You have your Gleason map here, right? Let's look at the stars real quick. So I'm gonna show something interesting to Geo. I'm not going to tell you what it is, but you could kind of look at it and figure it out. So we have
I feel like the dual pole right now, it's like having 4 wheels and a frame on a car. It's like, well, we got 4 wheels and a frame, but you don't really have we don't have like the engine or like all the interiors of like how it's all working. But anyways, go ahead. I just had that.
So the Gleason map, as you know, is the celestial sphere of the stars. You get a sphere and it's split apart at the South Pole. So if you look here on the Gleason, the stars at the outer edges. So we have, in regards to GPs, reticulum. So this is a freeze frame of the same thing, 2 different projections, but the same thing. Imagine look, we're gonna look at the continents, right? So South America's here, Africa's here, Australia's there. Let me hide the sun sphere real quick because that's irrelevant. So let's look at the stars here. With the celestial sphere split apart, just look. We have let's look at the names. We got Carina all the way over here, Volans all the way over here, and let's see another one that's kind of clear to us. So let's look at these two, Carina and Volans. They're this distance apart. If you were to imagine GPs as like points on the ground, that's how many miles, whatever that distance is. That same thing, Carina and Volans on the dual pole, is literally right here, right next to each other. So let me make this transparent.
It's just how it appears in the sky, right?
Yeah, however way you want to.
Southern star trails.
Yeah. So these 2 models, Antarctica, it's not the same size. One of them is obviously small. This one borders the outer edges. If you could see Carina, Volans, and Pavo, these stars in this small proximity is the outer edges on the Gleason.
Right.
Okay. In one full 24 hours as it goes around, it's simply going around on here. Let me see if I can turn the sun down real quick. It's kind of bright. Oh, it crashed.
Did you figure this all out yourself, by the way? Just Blender, just tinkering around?
Yeah.
Or?
Yeah, I had to do it for Concave Earth.
Cool. I just wondered if it was like, if you were like going to school for it, or if it was your profession, or if it was just like for fun on the side. Yeah, we just see a black screen so far. I mean, Elbow, isn't it fair if I were to say that if I say I don't see how it could be a different way? Like, I mean, if I'm not saying like for sure it can't be any other way. You know, I'm not saying 100%. You know, until I know for sure.
Yeah, yeah. I was just saying that because of Jaren, and he doesn't see any other way that it could be. You know, that's why he fell into that. You know, he fell in love with the Gleason, the AE map. So that's why I was like, hey, it's just remember, just don't be too attached to something.
Yeah, well, I'm not attached to a dual pole. I mean, I think the logic of the way the sky works with the ground, but I'm not like, I mean, that dual pole map, like I don't have any. I've never claimed that's like what the map is or anything. Like it's just kind of an outline.
Right.
But yeah, I hear what you're saying. There's always problems if to be like excessively dogmatic. Like on the search for truth, yeah, you don't ever want to be overly like biased or dogmatic with anything. But I mean, like, but if you know, would you say something like without curvature, I don't see any way it could be a ball? Like, wouldn't that make sense if you were to say like I don't see any way it could be a ball? You know what I mean?
Yeah, there's no possible way.
Yeah.
Something very interesting that I've actually discussed with my personal family is flat Earth. And my mom and my dad, you know, the reason I'm in existence, if they were to suddenly come out and say, hey, Andrew, did you know the Earth is flat? I would question them. Would that be valid? Incorrect? I don't think so. So that's where I come into play with a common sense type of basically just questioning reality, essentially. I'm a flat earther. I've tested it myself. I'm looking for someone to prove me wrong, and so far no one has done that. I'm not looking for Jaren as someone to the end-all be-all of scientific research.
I'm sorry, guys. Prove you wrong for what? I'm sorry. I kind of missed it. Sorry.
You hot mic Elbow?
No, I was asking Andrew what was he said. Proved him wrong. That nobody has proved him wrong, and I kind of missed the first part of what he said. I just wanted to see what he said.
If my parents came out and told me, by the way, yeah, the Earth is flat, and they did all these different types of research videos and or just watching videos on YouTube, I would question the integrity of what those videos are. But at the same time, I'm not going to just dismiss it because I've done my own tests, and I'm not going to necessarily say, hey, Jaren has done all of these tests, and some of them I've done with him. I'm not going to just absolutely accept it or dismiss it. But some people do. Some people get lazy. It's unfortunate, but it is what it is. I don't know exactly what happened with Jaren. I have some suspicions about it. But then again, I haven't talked to him on the phone or through a text message in about a year. That's fine. I don't care. Everyone has their own path of life they're going to be going through. And if it's flat Earth, globe Earth, concave Earth, hollow Earth, or simulation theory, or whatever else, I don't really care. Everyone has a different avenue.
Yeah, for sure. Everyone's unique and has their own way of going about things. And I know people speculate with him, like, oh, is he compromised or is an agent or something? And, you know, or there's just that he's just who he is and that's what he's going through. Oh, what was I going to say? Oh, did you hear like on that stream he did with Alan, one of the last ones that he got decent views on? Because I think his channel now, like he's still doing those trivia things and he's getting like hardly any views. But he did do that show with Alan like a month ago. And did you hear on that show like the contradiction? At the one part he was saying, you know, oh, Alan, I would love to come back to the flat Earth. I would love it for it to be true. That would be amazing. You know, if there's some way that I could be shown, you know, etc. Which is funny for him to even say that after all these years of, you know, it's like being shown. Like you've been showing other people this stuff. You've been saying like now he needs to, and he never found curvature. Nobody showed him curvature. So why would he? Why wouldn't he have just gone on the fence if anything, or just been like, I'm not sure what the map is. You know, it's so weird what he's done. But anyways, but then later in that same show, he was, you know, after Alan left, he was doing his like kind of darker rant where he was like, the Earth will never be flat. Your parents will never think it's flat. Your children, your children's children, you know, will never think it's flat in the history of all of humanity. It's like, wow, bro, like just that contradiction. On the one side, he's like, oh, Alan, if you can show me, I would love to come back to flat Earth. On the other side, he's like, it'll never be flat. It's a globe. I found the truth. So he's still running some like strong contradictions in his whatever he's, you know, been saying.
Yeah, it's kind of weird because I looked up to Jaren quite a long time because he was one of the pioneers to the actual subject. But then something happened. I have my predictions and hypotheses, but I am not going to present those unless Jaren is here. I will call people out to their face, but I'm not going to do it right now.
It was just out of spite. Going back and listening to some of his YouTube videos when he first started out, and he was getting shit from Globers. He was like, I'm gonna turn off the comments, and yeah, it's gotta be our fault because like he can't take criticism. That's what I feel.
Could be, yeah. Like some people are more sensitive to it than others. He was always kind of like isolated, it seemed, in the community. Like he never really came into Discord. He didn't do too many like open debates. He was always kind of like either on his shows that he could. I'm just kind of trying to play into what you were saying. Like, do you think that's because he also would do long rants? Like if someone did like say something about him, he would like spend 3 hours just like going over it, and defending himself, which is understandable. Everyone does that to some degree. Like if you're being strawmanned or misrepresented or something, you want to straighten it out. But I mean, I hear what you're saying. I kind of do pick that up from him, like his personality style. That maybe he's like more kind of sensitive maybe to criticism than others. Maybe
if someone calls like Geo, if someone were to call you out and just bring up like, oh, Geo's a pedophile or something like that, you would probably have something to say in regards to it. But no one's ever called Jaren a pedophile or myself. But if someone ever did that, yeah, there would be a certain level of scrutiny and explanation in regards to the response.
Yeah,
So,
I mean, I don't think Gio would have to defend himself for being called out for something he's not. What would he do? What would he do?
an extreme hypothetical type of situation, which would be completely reasonable. If someone were to do that to me, then yeah, that's like a legal kind of situation coming up, and can also be legal. As far as I know, Jaren's never been accused of doing any of that kind of stuff, but other people are gonna accuse him of doing other things that can damage his reputation. So I mean, like, it is what it is. I've never done that to Jaren or to Dave Weiss or to many other people, but it's really fun.
Yeah, if you're completely slandered or lied about, or someone just makes something up, then yeah, I mean, if one would want to defend themselves or say that's false or set the record straight, and if they're doing it chronically and keep lying, then it would make sense that some emotions could get stirred up, like frustration that someone's just saying something completely false, But then there's the other side of it, of just criticisms that are difference of opinion, and then there's the whole insults thing. People are getting insulted. I mean, Jaren did get attacked, as far as we all know, pretty severely. I mean, he already was in the the behind the curve thing, whatever, or behind that, what's it called, beyond the curve, that documentary thing. He was already in that, which he got kind of attacked heavily for that, and then now this. I mean, I think Witsit did as well, but maybe Jaren even got more. But it seems like those guys both experienced like a lot of people turning on him and freaking out.
But there's a difference. At least Witsit is more wise and waits and thinks about it before he actually answers. And what happened with Jaren is that he's just, whatever pops into his head, he just blabbers it out. Like except when he was over there, it's like, yeah, when he was in Antarctica or whatever. So that's why I'm like, he should be like, instead of like giving an answer, be like, yeah, we're gonna have to see what's going on. I mean, there is a 24-hour sun here, so I'm gonna get out back on paper and see what's going on.
Yeah.
He pretty much kind of threw the white flag, and he was still, at that time he was still kind of like, okay, yada yada yada. But then when people started saying like, started saying all this mess and trash, that's when he's like, you can see he flipped. Like, you know what? Screw it. Where's the ball? Blah blah blah. And that's where he kind of, that's the way it feels like he did. Just then come back to kind of to think about it, talk about it, or whatever. He just said, especially when he said before he left, doesn't matter what the sun does. The sun doesn't dictate the floor. He said that before he got there, but yet then he just flipped around after everybody started saying, "Oh, he's a chill, yada yada yada."
Yeah, throwing out those type of insults or accusations is not going to be necessarily beneficial at all. Well, maybe in some cases, but when Jaren was doing his whole the members only kind of once per month situation, I actually asked Will Duffy, said, if you see a 24-hour sun there, is that going to conclude your evidence? Or if you see the sun set, will that conclude your evidence? And he said, yes. I was like, all right, cool. And then I can go on for a long time about this, but either way, I even said, this is going to go on for 2 or 3 years. People are not going to give it up or let it go. But yeah, Duffy has now resigned from doing any of these episodes, debates, or presentations. He retired, apparently. Well, I asked that to him.
He did through a kink. I mean, say definitely did the service he needed to do, just because. I mean, a lot of the I want to say quote unquote not religious, but like so dogmatic people that was so married to something that they weren't really sure of got exposed.
Well, the thing about it too is,
yep.
What if we were wrong and he was right? I'm willing to accept being wrong. I like being wrong.
Who was wrong?
No, I'm just saying in general, I like being wrong. That way I can learn. It's like the general premise of engineering. Be wrong.
Yeah, you're right. Yeah, you only learn from your mistakes. You don't learn from your accomplishments. You accomplish something and like, hey, okay, I can accomplish this. If everything you do gets accomplished, then you have nothing to learn.
And I don't trust Duffy, by the way, just putting it out there. But I did actually ask him. I was live on camera, so was he. And that's what I asked him. I don't trust him.
Dude, when a pastor says that lion will not, the lion is acceptable in the Bible, then.
Aaron, oh, did Elbow just drop out? Okay, he just left. Maybe he had to go. Well, I was just going to comment what he said, but if he's gone. No, I was just saying the thing with Jaren, like, it is true between Jaren and Witsit, how Jaren was more like on that one, the first stream that they did when Jaren, was much more like, well, he said something like, when you're wrong, or, something like that. To where it kind of like, instead of him just kind of being like Witsit was more neutral, like, okay, there is 24-hour sun here, there's more to think about, etc. Whereas Jaren was more, kind of, that's why he was put on the front of all the news things and, flat earthers wrong in Antarctica kind of thing. So I would imagine a lot of the community already was kind of targeting him even more than Witsit, just because of that. And then, like Elbow was saying, there might have been kind of a way in which the combination of that and then everybody starting to like turn on him even more, and then maybe whatever with his psychology and however that all kind of played out, because it did seem like he was like in a very reactive state. Trying to just be like, well, then screw all you guys, I'm just going to eradicate all of you from my life kind of thing, which is...
Yeah, it's kind of unfortunate that he was put in that position. And not necessarily if he wanted to be, but it's just, as you were just saying, Gio, yeah, he was in that position. I don't know how I would react, because I was never in that position. So it's kind of fucked up. But either way, he did what he did. He went where he went. And he reacted to it. So I have no idea how I would even deal with that. So it is what it is. A very, very difficult situation to deal with.
Damn, my connection dropped. I don't know how long I was out there by myself.
Well, you owe us money. Kidding. Joking.
Well, it's been a year, huh? Since they were there. It's almost about a year, right? And nobody went this year that we know of? No one was there for the marathon thing, or we're not going to get any more footage this year or anything, sounds like?
Yeah, I think that's going to be a little more complicated. Yeah, some people want to go there for a marathon or for, I think, a marathon, as far as I know. Like Run Boston Bear, JT. Yeah, he wants to go there. But I don't know how it's going to work out. When it comes to people wanting to actually do one of these expeditions, it's very expensive, very dangerous. Okay, well, that's fine. But at what point is there going to be enough money to be funding it? Which is the valid question, in my opinion.
Well, now that we've determined that Tonga isn't the Hunga or whatever is actually the center of the flat Earth, it should be a lot easier to get there.
Tonga?
Yeah, there's a country called Tonga, but then there's an island group called. There's an island group, and one of the islands was something like Tonga, Hunga, Tonga, and in 2022 it erupted with an incredibly massive explosion, which created an infrasound shockwave that traveled around the world multiple times and got recorded on barometers on weather stations all over the world multiple times. And so, because of the speed of sound, we now know the distance between that former island and every city on Earth, which means that that island has to be the center or very near the center.
I've never heard of that. I know what Tonga is, but I've never heard of that ever until just now.
I'll DM you a nice video made by Science It Out on it.
Okay.
It's not too long and pretty nice.
I like long videos.
Well, you could play it on half speed.
My attention span is a little bit higher than a goldfish.
Jesse, what is your estimate of how many people on Earth do not think Earth is a globe? So that includes globe skeptics that say nope, not a globe. It includes all people who live in the Amazon jungle or third world countries or wherever else where they may not have a schooling system from young ages, and or they still have their traditional cosmological viewpoints or traditional culture. And it includes all the people that are of our age and who have shifted their cosmological outlook to not be a sphere. What do you think that number is? Like what percentage of the population, or how many million, or how many, if you had to guess or estimate?
Well, I could estimate more accurately for the United States, and I would say probably less than 1 in 1,000. I'm not really sure how to even quantify it for, say, a native village out in the mountains or the plains that's never had contact with the outside world and is not even aware of the argument, though. But I suppose that's a pretty small number of people. Even if all those people actually were aware of the argument and did deny or doubt or question or were skeptical of the globe, that still wouldn't change the global percentage. And I would say that the majority of the world is connected enough to know about the argument, and I would guess it's probably around 1 in 1,000 still globally.
Well, that's only 343,000 in the U.S. roughly.
Well, isn't that approximately what the number of subscribers to Dave Weiss's app that was found when someone examined the API that had the customer database?
Oh, I don't think that app is a very good. A lot of people are skeptical of that app. It could be some number to look at, but I don't necessarily think that app is like owned by everybody who questions the globe and all that. I mean, that's just one guy and his app thing. But I mean, there could be some demographics, I suppose, that could be gleaned from it. So I mean, 1 in 1,000 for the 8 billion population, that'd be 8 million. Ruhif said he thinks 5 to 10 million. So your number globally, planarly, globularly would be 8 billion or 8 million in total. Is what you would say 1 in 1,000?
Yeah, it's just based on like it was. I mean, I made it into my 40s before I actually even met a real flat earther, which was in real life, and I'd met a fair number of people by then because I've worked in customer service and now I run my own sole proprietor business, so I do meet a fair number of people in my area. And, I met a lot of people going to churches all my life, and I never even knew that there was such a thing until I met this one customer in the end of 2018, which is what launched it for me, because he told me to check into it, and I did. So, since then, let's see, I've met 3 other real-life flat earthers. 2 of them saw me on the beach with my theodolite. And maybe 4 others. One of them, when I showed him how, because he likes to go hiking in the mountains, when I showed him how mountains that were higher than you could look lower than you, then he understood enough geometry to realize that Earth wasn't flat, and so he gave up flat Earth. And the other one was a customer's wife, who I'd never actually talked to, but I heard that she was a flat earther. So I've had a pretty good exposure to people in real life, and not very many of them are flat earthers. So that's what I'm basing my estimate on.
Yeah, fair enough. I mean, that's your experience. I mean, it is fair to say, though, that everyone you meet may not be telling you about it, kind of thing. Like I might go out in the world, meet all kinds of people, and not necessarily tell them what I think about the Earth necessarily, So there could be people that just didn't bring it up to you, right? Or didn't talk about it, even though they may have not thought Earth was a globe, potentially.
I mean, obviously it could be, but now looking back at all my interactions with flat earthers and anti-globers and whatever, since the end of 2018, I think not very many people, because I would recognize a lot of telltales of a flat earther, even if they didn't come out and tell me. I think. And so I think that not very many were flat earthers that I didn't know about that I met. If that makes sense.
All right. Well, yeah, I just don't know what you're including meeting. I mean, if you're checking out at a grocery store and the cashier is checking you out, they may not think the Earth is a globe, but you wouldn't really bring it up to them, right? So technically, you could have run into a lot more. That's all I was saying. There might be a lot more that just didn't even say anything about it. I mean, maybe you wouldn't think a lot more, but some. There could be some people you brushed by in the grocery store that were flat earthers that you just didn't, that they didn't, you know.
I guess it could be, but it's like, you know, you don't really talk with the clerk. They're like, oh, that'll be $14.95, and you hand over $14.95, and that's that. But when you're working in customer service or running your own business, you actually end up talking with people a lot more because, you know, you're there working on their truck or whatever, and they're walking around and they're bored, so they start talking, you know, which is exactly how I got into all this. I was working on something for a customer, and he was bored, hanging around while I was working and on it, and and he's talked about it. So
your truth radar went off. You were like, I gotta look into this.
Well, at first I thought he was joking, but he wasn't, so I looked into it.
That same type of reaction is how a lot of people actually will respond, such as Bigfoot. I am not a proponent for Bigfoot at all. I've researched it as much as I possibly could, but I cannot get on board with it. And then there's Flat Earth. And then I researched the moon landing extensively, way more than Flat Earth even. And then there's other people that have tried to convince me of other things as well. So Jesse, my question for you. What was the first point of Flat Earth that you ever encountered? Like, I think you said your friend. And then
Yeah.
what did you do? What did you do after that?
Well, I started checking up on the things that he asked me to check up on, and he presented me with several claims. I think, of course, this was December of 2018, so I'm doing my best to remember this, but I believe he told me that mass did not attract mass, and that things did not drop in the distance as they would on a globe, and that gyroscopes did not show Earth rotation. And so I thought, well, cool, this is all stuff I can test, you know. This is, I can test these claims. And, oh, probably he told me that the horizon line's always straight, too, because he was probably influenced by 200 proofs that Earth is not a spinning ball at the time, because this was, you know, at that time.
Oh, the Eric debate thing, right?
Yeah. A lot of people quoted that. But anyway, so those were all things I could test. So I'm like, okay, cool. So I started testing those specific claims, and I found every one of them to be false, which doesn't mean Earth isn't flat, but it kind of, you know, it's a trying to start someone out on a new big truth with claims that are testably false is not a good way to start them out. You know, the truth doesn't need lies to survive, right? So maybe, who knows, if some different, if I had been started out on different claims that either I couldn't have tested or that were true, then who knows, maybe I'd have become a flat earther.
Okay. So what do you think it means for someone that says, I'm a flat earther? Do you have a perception or indication of what you might think?
I don't know. I don't recall ever having heard one say that. I don't think they like to say that. I think they would rather say the Earth is flat or NASA is fake or something.
Well, NASA is, yeah, it's abstract, but if I were to say to you, Jesse, I don't think the Earth is a sphere. I think it might be more horizontally inner. Or not just me, someone else.
Okay. Was that a continuation of your question? What if someone told me Earth was flat and then you reworked
Yeah,
it to...
it was a double type of a question. Yeah, open-ended kind of question.
So in other words, you're asking, what's the first thing I think when someone tells me that it communicates to me one way or another that they think Earth is flat or not a globe?
Okay, so me, Andrew Baker, says, Jesse, I don't think the Earth is spherical because I have a certain amount of evidence to it and I've tested it. What would you say to me?
I think, well, obviously, I'm always interested in new evidence. I would want to see the evidence if possible, but I think you mentioned that was on your drive that got lost or something. But you could tell me, you could still tell me about your evidence, and I think it's lasers over lakes, which I do not dispute at all. But I think what I would want to examine was, or to try to go over with you, was to examine the assumptions you made and see if all of those assumptions were true or if some of those assumptions were observably false. Right? Like if you have, if part of your logic has the assumption that light cannot and will not naturally bend over a lake, then that is a false assumption, and you would want to rework your conclusion to exclude that false assumption, obviously, because light observably can and does bend in natural conditions over water. And obviously, if it can bend equal to or greater than 8 inches per mile squared, then all the long-distance laser tests are also possible on a globe, which means they're no longer exclusive to flat or concave. Did that answer your question, or did I misunderstand?
Yeah, a little bit. It was trying to bring up or to respond appropriately without strawmanning. That's good enough for now. I will formulate a response.
Perfect. Anytime, just let me know whenever.
Yep, it's fine. It was a bit of a straw man.
On my part or on your part?
On yours.
Well, I sure didn't mean it that way.
I was not insinuating that you did it on purpose.
What's that?
I did not insinuate that you did it on purpose.
Oh, good. Okay. So long as it was an unintended straw man. Unintended, unintentional straw man.
Yes.
Okay. That might be more just a misunderstanding on my part.
It's okay.